organizing committee members, my dear colleagues and my students. It is indeed an honor and privilege to welcome you all to FISAT for the 5th International Conference on Structural Engineering and Construction Management. The presence of international delegates and experts in the field of structural engineering clearly indicates that FISAT is in the right direction, moving towards its excellence in teaching learning process. As mentioned by the chairman, today we are celebrating the World Environment Day. Structural engineering and construction management is very critical for the sustainability of this world. The engineers who build this world should sustain this world also. That should be the motto of SECON'24. I know that with the advent of artificial intelligence and machine learning and its encroachment in the different fields of science and technology, it has gone deep into what is known as structural engineering as well as construction management. So we have coined the theme of this SECON'24 in line with that, digital twins in construction project. With that, we can able to visualize the things right from the project, the beginning of the project till the end through virtual realization. It's a apt theme at this moment. I would like to congratulate, I am very much grateful to the Department of Civil Engineering for organizing such a wonderful international event at FISAT, where FISAT is in the process of its going to that higher level. So I congratulate the Department of Civil Engineering FISAT for organizing such an event. I am confident that discussions and collaborations that emerge from SECON'24 will pay for a significant advancement in this field. I wish all of you to have a fruitful and enriching experience in SECON'24. Thank you.
Thank you, sir. The theme of this year's conference is at the heart of our discussion and advancement. To introduce the theme of SECON'24, we are honored to have our esteemed convener, Mr. Srirath. Sir, please.
Respected dignitaries on and off the dais, my dear colleagues and students. As the convener of SECON'24, it's my honor to elaborate on the theme of SECON'24. The construction industry is changing due to artificial intelligence in a number of ways. By employing AI to generate digital twins of their projects, construction companies can save time and money by testing out various scenarios prior to starting construction. By producing 3D models of buildings and other structures quickly, software driven by artificial intelligence is assisting engineers and architects in their design work. AI is also being utilized to raise construction site safety standards. Construction businesses may significantly increase their management, speed, and efficiency by integrating AI into their workflows. SECON'24, the 8th annual and the 5th International Conference, is organized by the Department of Civil Engineering at the Federal Institute of Science and Technology in Kochi, India, in collaboration with the Indian Concrete Institute, Kochi Center, the Institution of Engineers, India, Kochi Local Center, the Indian Green Building Council Student Chapter, the Indian Society for Technical Education, FISAT Chapter, and the Builders Association of India, Angamali Center. The conference will focus on the main theme, digital twins in construction industry, as well as the 10 tracks that will examine the breakthroughs and innovations in various fields of civil engineering. In the course of 3 days, The conference intends to become a platform for researchers to present, discuss, and bring out the outcomes of the research and developments in the broad domain of civil engineering, with focus on leveraging AI in their construction workflows and and the development in infrastructure. SECON'24 will be a hybrid conference enabling participation of all delegates around the globe, both in person or through online media, making the conference accessible to all. The previous editions of SECON conferences since 2017 have honored prodigious success and appreciation, and the organizing committee is confident that SECON'24 will bring conspicuous benefits to researchers in academia and industry, practicing civil engineering, academicians, architects and developers, postgraduates and graduate students. Selected papers from the conference will be published in this corpus index lecture notes in civil engineering published by Springer Nature. The aim of the 3 days conference is to thrust research outcomes from research and development agencies, industry and academia along the following 10 tracks. Advances in building information modeling, advances in earthquake engineering and soil dynamics, applications of machine learning and artificial intelligence in civil engineering, applications of GIS and remote sensing in infrastructure management, construction management, quality, safety and risk assessment, advanced computational and experimental studies in civil engineering, innovative materials and sustainable practices in construction industry, rheological investigation of construction materials, repair and rehabilitation of structures, and urban and transportation infrastructure planning management. Thank you.
Thank you, sir, for an insightful theme presentation. Now, we move to a significant part of our ceremony, the lighting of lamp. We are honored to have our chief guest, Engineer Cornelis Allen Buke, technical consultant, primarily focused on sustainable architecture from South Africa, to light the lamp and inaugurate the conference. I also invite all the other dignitaries on the stage to join him. Thank you. Now I invite our esteemed chief guest, Mr. Cornelis Allen Buke, to deliver the inaugural address.
Good morning, everybody. First off, thank you for everybody. Thank you for inviting me. It's a privilege for me to be here, being the foreigner and all that, you know. But, and I think everybody has already said all the good things that needs to be said. So from my side, I can say thank you for this, and let today be a start of a new day, a start of a new thought, new intelligence and new memories. So from that, welcome everybody. Yes, let's start with a big opening act. Thank you so much.
Thank you, sir. Now, I invite Dr. Rahimi A. Rahman to speak a few words.
Hello, testing. Can you hear me?
Yes, sir.
Thank you to Federal Institute of Science and Technology for the invitation, and I hope SECON 2024 will achieve its aim and objective like the previous conference. So yeah, let's hope for the best. Thank you.
Thank you, sir. I cordially invite our guest, Dr. Anand K.S., Assistant Professor, Department of Civil Engineering, SRM Institute of Science and Technology, to share his valuable insights.
Good morning, everyone. Really, I thank everyone from FISAT for this great opportunity, and we will be waiting for every year SECON, like what will be the theme, and to participate. All my scholars and even my students for past 4 years, we are aligned with SECON. I'm so happy to see everyone, and I'm so happy to be here in FISAT. Thank you, everyone, and a special hi to Rahimi. Okay, so. Fine. Thank you. Bye.
Thank you, sir. It's my privilege to invite Dr. Anil Joseph, Chairman, Indian Concrete Institute, Kochi, to deliver his thoughts.
Good morning, all, and Chief Guest and my good friend Alan, the President of the function and the Director of FISAT, the dignitaries on and off the dais. Indeed, it's again every year this meticulously being done. The SECON team is coming up every year and coming up new innovations which is happening, keeping the students abreast with the latest technology. So congratulations to the organizing team for coming with this thought process and excellent ideas to keep it happening every year. I think everybody got told 1 or 2 minutes ago, I thought I will take 5 minutes. So there is a lot of surplus times happening. Why this sort of meetings is important? Where is civil engineering or the engineering is heading to? Especially civil engineering. If I was just the other day I had a meeting with the ISIT chairman. So he presented me with a book, The Vision of Engineering in 2047. And I was going through the records and I see that the civil engineering is becoming an endangered species. We had 3.5 lakh civil engineers which were coming in, is now at 76,000 in India. Whereas the computer engineers has gone up to almost 5 lakhs. So civil engineering has come down from an intake of 3 lakh to 76,000. And civil engineering is not totaling 50% of the engineering colleges in the country now. So where are we heading? Recently, I had a meeting with the assistant collector here, who was an alumni of IIT Kanpur, and we just passed out, 22 passed out. He was addressing the conference of ICI, and I was interacting and I was telling that there is something fundamentally wrong in the engineering system which is happening in the country. And he was telling that of the 120 engineers which passed civil from IIT Kanpur in the 2022 batch, only 6 is pursuing civil engineering. The rest has gone. So the intake has come by 1/5. The output is not coming to the engineering, and we are very much worried to get the juniors. So we started structural engineering maybe last 30 years. We have done almost 3,500 projects, accounts to about 30% of the high-rise industry in the state, and also going on to do the demolition across the country. So like pointed out by the sir, so it is very important. See, because now the construction has to think of destruction also, because the time is coming in, demolition will become part of the construction, because all the prime properties are occupied building and the life is 25 to 30 years. It get outdated due to technology. Even the 100 years life is there. So we cannot bring the marine drive in. So we have to demolish that and construct. So I always tell that the first step in the future will be demolition before construction. So that is essentially needed in this World Environment Day, to demolish without affecting the sustainability and the environment should be our theme which we should focus on. And for the young engineers sitting here, don't leave civil engineering. Civil engineering is a beautiful subject. Stick to that. There is a lot of changes happening in civil engineering. Artificial intelligence and machine learning, like the TIN system pointed by Sridhar, it is going to revolutionize civil engineering. And if Tesla can drive a car without a driver, the future will be that with the images and prediction, you will be able to work out what is the stress happening on this column, or what is the type of the soil below. So that is happening in a tremendous way. We need civil engineers sticking to that. And this sort of conference, please pick up. We badly need good structural engineers in the field. So stick to your profession and let us make sure that we correct the system which is happening. And we also don't know. I always say that there is a minimum wages act. Minimum labor wages act is there. There should be minimum salary act for engineers, especially civil engineers. There should be a minimum salary act. I also don't know how to correct it, but I know that essentially we need steps to do that, and it has to be corrected, and a constant effort has to happen. And let us make sure that we are creating a strong and safe India, because the safety and the durability, a doctor can kill one man at a time. We engineers can kill many. So make sure that the life of people are in our hand. And no, I'm talking with the last 30 years, I'm seeing that it is depleting every year. We cannot get a person, a good engineer from an interview. So to get a good junior, it's a challenging task every time. So we wanted to hang our boots because it's a very stressful job. But then there are no good juniors coming up, but there is huge scope. Make sure that we are doing that, and India is going to make change. Americans constructed 100-story building way back in 1920s. The Empire State Building, the foundation stone was laid on 30th March 1929, and exactly after 368 days, a 103-story building was created in New York, Empire State Building. Today, India still don't have one 100-story building. So India economy is going to be the leading one. There is going to be huge demand which is going to happen. So please, young engineers, stick to your profession, contribute to that, and we together will try to make sure that you are comfortable. We are getting the Professional Civil Engineers Act. Already it is passed in Karnataka. Soon it will be passed in Kerala, and we will have the minimum act that we don't reach our younger this latest computer engineers, but we will try to match with what is basically needed for a good engineer, and wish you all the very best. Thank you, and all the best for the conference.
Thank you, sir. Now, I would like to take this opportunity to welcome Professor Elham Fasagi. She is from France. She took a lot of pain to come over here and present her paper. She is the author of this conference. Welcome you, ma'am.
Thank you. Let's extend a warm welcome to Mr. Shaitan Kuriakos, Chairman, Builders Association of India, Angamali, to share a few words.
Chief Custodian de Landuc and Chairman, dignitaries on the dais, off the dais, dear students. I am honored to represent the Builders Association of India, Angamali Center, and thrilled to witness the enthusiasm of our future engineers and innovators. BAI, Supreme Body of Construction Industry, has been shaping the built environment since 1941. Our Angamali Center, a vibrant chapter, is dedicated to skill development, knowledge sharing, and the community service. I am proud that FISAT Civil Department is our students chapter, and we aim to bridge the gap between academia, and industry, providing hands-on experience and exposure to cutting-edge technologies. We are committed to narrating talents and fostering growth in the building environment sector. Our members comprise professionals from various disciplines including architecture, engineering, construction, trading, contractors, and related fields. I would like to extend my heartfelt gratitude to the management and the faculty of this esteemed institution for their unwavering support and cooperation. Your collaboration has been instrumental in shaping the minds of our future professionals. Let us work together to build a brighter future, and I wish the students all the best on their endeavors. Let us continue to work together to build a brighter future for our industry and our community. Thank you for your attention, and I wish you all the best. Thank you.
Thank you, sir. We are pleased to have Engineer K.S. Babu, past Honorable Secretary and Executive Member, Institute of Engineers, Kochi Local Chapter with us today. I invite him to the stage.
Good morning to all. Our respected Chief Guest, Alemberg, and distinguished guests on the dais and off the dais, dignitaries and scholars, faculty members, and students. I am happy to be here in this auspicious occasion of inaugural ceremony of SECON'24 on the theme Digital Twins in Construction. See, I came to know that for last 7 years, this conference is conducting in well-planned manner, and I would like to congratulate all behind this in organizing this conference. So this time the main theme is digital twins, and it is sub-themes are regarding artificial intelligence, 3D, and sustainable development, sustainable construction, and environmental friendly construction, etc. All these are related, all these are very much important during this this time, and mainly this artificial intelligence and other connected subject can utilize for the timely completion of the projects. Especially then that's why we can save time and money, important factors relating to this construction industry. And importance, and this importance is already explained by our Dr. Anil Joseph, who is chairman of the Indian Concrete Institute and our chairman of Civil Engineering Division of Institution of Engineers India. Actually, I am representing this Institution of Engineers India, Kochi Local Center. We are the second largest local center among 124 centers in Kerala, and we are also conducting this type of seminars and fortnight technical presentation, offline and online mode, and it is useful to all these things. All the subjects are covered. In this occasion, I extend all support and great wishes to the success of this international conference. And meantime, I request all of you to join with us during October 17th and 18th. A national civil engineering convention is conducted or hosting by our center at Kochi, and the theme is on emerging trends in civil engineering. Once again, I express my sincere thanks and best wishes to the success of this conference. Thanks to all.
Thank you, sir. I invite Mr. Janet J. Kachapilli, Treasurer, Governing Body FISAT, to enlighten us with his words.
Chief Guest of the Day, Mr. Alan, Dr. Anantu, other dignitaries on the dais, the participants of SECON'24, dear faculty members, and my dear students. Mr. Shyam was giving a good thought for the day. When the developed countries has advanced a lot in the engineering or architectural area, our country is still lacking behind. What he said is very correct. But my dear friends, our country had a past with rich heritage, with architectural wonders has contributed to the world. Look at Taj Mahal, look at Qutub Minar, even our Sri Padmaswamy temple. 2 months back, during the equinox day, the sun was visible in the Gopuras. Look the precision our ancient people has created the wonders. We have a rich tradition. Where we have lost it. Sure and certain, SECON'24 should be a thought. We should take back that heritage. We have a rich culture where our architects in the ancient days created the wonders in this world. We should not forget it. We have that tradition, we have that power. The young students, what he said is very correct. You have a lot of opportunities with the advancement in technology, AI, and other tools. We still can create wonders, architectural wonders, structural wonders in this world. Sure and certain, SECON'24 should be a good platform to develop such talents among our students and the participants of this conference. I congratulate the Department of Civil under the leadership of Dr. Gigi to take this initiative and wish all the success for SECON'24. Thank you.
Thank you, sir. I request Dr. Mini PR, Vice Principal FISAT, to address and grace the occasion.
Respected dignitaries on and off the dais, a pleasant good morning to one and all. I'm very happy that once again FISAT is the venue for one more international conference, this time by the Department of Civil Engineering. And as before, SECON has always been a proud feather to be added to the cap of FISAT. I know the amount of hard work that this department has been taking to ensure that this conference is conducted well, especially since this time they are organizing it in the hybrid mode after being online for a few times. So I congratulate the department and I wish all success to the smooth conduct of SECON 2024. Thank you.
Thank you, ma'am. I invite Mr. Shyam Kumar B., Director Operations, Quadlink, co-sponsor of SECON'24, to the stage along with his team, Mr. Lijo Thomas, Ms. Sri Lakshmi Suresh, and Ms. Rama Ramachandran for a small presentation.
Good morning all. I'm Reshma, Faculty Academic Researcher at Quadlink. Quadlink, in association with SkillTech Academy, are happy to introduce Quadlink, in association with SkillTech Academy, are happy to introduce a program for construction professionals, empowering the future of construction industry. First of all, I wish you all a very happy Environment Day. Quadlink's vision as finishing school revolves around empowering students to reach their utmost potential by educating, improving quality, upgrading skills, innovation and integrity, productivity and progress, which leads to a successful career, and we call it Equip. Our courses are designed by industry experts and it is a balanced mix of classroom sessions, hands-on trainings, software sessions, soft skill enrichment, addressing relevant industries. At Quadlink, we also provide a comprehensive support service including career counseling, personality development, aptitude, assessments, placement assistance, and guidance in identifying your passion. Scholarship programs are also available for underprivileged students, addressing 60% of their academic expenses based on their academic excellence. Our center is accredited with central as well as state bodies like Scientific and Technical Education Department, STED, and Additional Skill Acquisition Program, ASAP. We are also affiliated with CADDISC and RIB-CCS Candy for software training programs. Our mentors and group chairs are the backbone of our success and wisdom. We encourage you to discover your route to success through the guidance of seasoned faculty members. Mentors oversee the curriculum, ensuring its alignment with market demands. We provide personalized support to our students, helping you not only navigate but also thrive in the ever-evolving market environment. We are happy to announce our upcoming programs under SkillTech Academy, addressing recent demands on advanced construction methods and technologies in steel structures. First program is LGSFS Technology Training Program for a duration of 6 months. The light gauge steel structure frames training program is designed to provide participants with comprehensive knowledge and practical skills with theoretical reinforcement and in light gauge steel frames for construction. And the second program is pre-engineered buildings for a duration of 6 months, a comprehensive curriculum for a skill development course on pre-engineered buildings, covering a balanced and theoretical knowledge as well as practical skills. We also provide industry bridge programs for fresh graduates, empowering them to industry standards. This course includes theoretical sessions, software trainings of RIB, Candy, and AutoCAD, on-site training and soft skill development sessions in offline mode, the duration of which is 3 months. We also provide short-term add-on programs and faculty development programs at colleges and academic institutions on specific requisites. Also, we undertake training programs for construction companies for their staff as well as the new recruitees. Apart from these, we offer software trainings to construction professionals in various sectors like drafting softwares, which are AutoCAD 2D and 3D, interior designing softwares, which include some of softwares like AutoCAD, 3ds Max, SketchUp, Lumion, etc. Architectural designing softwares like AutoCAD, 3ds Max, Revit Architecture, Lumion, these are the few. Structural designing softwares, which include Tekla Structures, Revit Structure, Start Pro, ETABS, ANSYS Workbench, and all. Building information modeling, which are Revit MEP and Navisworks. Estimation and planning softwares, including RIB Candy, Primavera, and MS Project. Let's take this step towards a successful career in construction. For more information, please visit our website or you can contact us to know more about our programs. We thank FISAT Civil Engineering Department and program coordinators for the given opportunity. Thank you all for your kind attention and valuable time. I wish the very best for SECON'24. Let's build the future of construction together. Thank you.
Thank you for this wonderful presentation, Team Quadlink. On this momentous occasion, we are delighted to present a significant event, the release of our newsletter. I'm honored to invite our chairman, Mr. Shimit PR, to hand over the newsletter to our esteemed chief guest, Mr. Cornelis Allen Buke, for its official release. Please join me in welcoming them both to the stage. Thank you. I also invite our chairman, Shimit sir, to kindly hand over the gift and memento to our chief guest, Mr. Cornelis Allen Buke, as a symbol of our gratitude. Thank you. I would like to invite Janip J. Kachapilli, Treasurer FISAT, to kindly come forward and present the memento and gift, and also request our guest, Dr. Anand K.S., Assistant Professor, Civil Engineering, SRM Institute, to please come forward and accept the token of our gratitude. Thank you. I request Dr. Jacob Thomas, Principal FISAT, to do the honor of presenting memento, and also invite Dr. Anil Joseph, Chairman, ICI Kochi Center, to receive the memento. Thank you. I request our principal, Jacob sir, to kindly stay back on stage. Now, I would like to invite Mr. Shyam Kumar B, Director Operations, Quadlink, co-sponsor of SECON'24, to the stage to receive the memento. Thank you. It's my pleasure to invite Vice Principal Dr. Mini PR to the stage to present the memento. May I now call upon Mr. Shaijan Kuriakos, Chairman, Builders Association of India, to receive a token of our appreciation. Thank you. Finally, I invite Dr. Gigi Anthony, Civil Department HOD, FISAT, to present the memento. I request Engineer K.S. Babu, Past Honorable Secretary and Executive Member, IVI Kochi, to come forward to receive the memento. Thank you. To express our gratitude to all who have made this event possible, I request Mr. General Saud, Convener SECON'24, to deliver the vote of thanks.
Good morning, all. Esteemed guests, delegates, and faculty members. As the convener of the 5th International Conference on Structural Engineering and Construction Management, SECON'24, I stand before you today filled with immense gratitude. The event wouldn't have been possible without the unwavering support of a remarkable team, my department. Firstly, I would like to express my sincere thanks to our esteemed chairman, Sri Sumit PR, for his guidance and leadership throughout the endeavor. I also extend my appreciation to the entire management team of FISAT for their unwavering support in making the event a reality. Thanks, sir. A special word of thanks goes to our respected principal, Dr. Jacob Thomas, for his continuous encouragement and belief in the potential of this conference. I am also grateful to Ms. Mini, our Vice Principal, for her support too. I'm also very grateful to my co-convener, Mr. Sridhar, for his tireless efforts and dedication in bringing this event to fruition. Thank you. I would like to acknowledge the invaluable motivation and support provided by Dr. Gigi Anthony, Head of Department, Civil Engineering. Her enthusiasm has been instrumental in driving this conference forward. Our deepest gratitude goes to Dr. Rahimia Rahman from University Malaysia Pahang, who, despite joining us virtually, has been a constant source of support and encouragement. Thank you, sir. We are also thankful to Engineer Alan Buke and Dr. Anand K.S. for their presence and invaluable guidance during the planning and review stages of the conference. Thank you, sir. We are incredibly grateful to Mr. Shyam Kumar, Director of Codling, and his team for this generous support. Sorry. We also extend our appreciation to the representatives of professional bodies from ICI, IEI, ISTE, BAI, and that of AC in absentia for their invaluable guidance and support. A heartfelt thank you goes out to Ms. Renuji Atchison and Dr. Kavita P. for their dedication and countless hours spent meticulously planning and organizing the various events of SECON'24. I'm indebted to Ms. Nirja Nair, Mr. Abjitar, and Mr. Ibn Thomas for their time and unwavering support throughout the process. I also thank Director of FBS, Joshua Sir, and all other HODs present here. Thank you, sir. I also thank my faculty colleagues for their support, motivation, and time over the last 7 months during which SECON'24 was conceptualized and executed. I would also like to thank all our reviewers and chairs in absentia who did a meticulous job in selecting the best papers out of the 440 odd abstracts that were received for the event. We are particularly grateful to the PTA of FISAT for their unwavering support, which has been instrumental in the success of this conference. I also thank all the student volunteers for all their time and support to the event. We are also grateful to Mr. George from the Accounts Department for his assistance. Finally, I would like to express my sincere thanks to all the authors who have contributed their valuable research and are present here today. Your work is the heart and soul of this conference. Thank you all. Last but not the least, I would like to express my deepest gratitude to the Almighty for the constant motivation and guidance that has seen us through this journey. Thank you all once again. To everyone who has been part of SECON'24, your contributions, big or small, have made this a truly memorable event. I am also happy to convey to all that the conference is a supporting event now to the United Nations Environmental Program's World Environmental Day 2024 # Generation Restoration Initiative. Thank you all. Have a great day.
Thank you, sir. As we stand on the threshold of a new chapter, let us reflect on the significance of this moment and the responsibilities it entails. We officially conclude this inauguration ceremony. Thank you. I kindly request everyone to rise for the national anthem.
अधिनायक जय हे नायक भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
The official event has come to an end. We'll have a tea break and please assemble back for the keynote session at 11 a.m. Thank you.
Hello. Hello. Sir, am I audible?
Yes, hear you. Kavita.
Yes, sir. Maybe I can. Okay. Now you can see me, right? Sir,
Yeah, see you. Yes.
sir,
Yeah.
it is a break for 10 minutes. It, tea break.
Yes.
We shall start maybe by 10:55, sir.
10:55. Okay.
Okay. Let them come in. I shall give you the prompt so that you can start the presentations. Presentations, you will be doing the presentation from there, right?
Yes, yes. Yeah, I will share the slides from here. Yes.
Oh, okay, okay, sir. Okay, thank you. Thank you, sir.
Yeah, thank you, Dr. Kavita.
A warm good morning to one and all. Welcome to the first keynote session of SECON'24, the fifth international conference organized by the Department of Civil Engineering, FISAT. I would like to introduce the first keynote speaker, Dr. Rahimia Rahman. Dr. Rahimia Rahman is the Deputy Director at the Innovation and Commercialization Management Center and Associate Professor of Construction Project Management at University Malaysia, Pahang, Al Sultan Abdullah. Holding a PhD from Arizona State University, he boasts a rich academic history, including an, a master's and bachelor's in engineering in civil and environmental engineering from Saitama University, Japan. He serves as a visiting researcher at Daffodil International University and was affiliated with the Bartlett School of Sustainable Construction, University College, London. His research group focuses on sustainable development in construction, exploring decision-making tools, green construction, and technology adoption. The upcoming keynote session will delve into the precision of digital twins in construction projects. Dr. Rahman's achievements include multiple excellent paper awards and recognition as an outstanding reviewer for the Journal of Architectural Engineering. With more than 100 publications, a national technical report, and guidelines to his credit, he has made significant contributions to the field. Dr. Rahman is also on the board of directors at the Association of Engineering, Project and Production Management, EPPM. He also leads an ethical innovation approach, emphasizing a commitment to advancing industry knowledge responsibly. I welcome you, sir, for this session.
Hello, testing. Can you hear me?
Sir, we can hear you, but
Hello?
yes, sir.
Yeah. Okay. So, good morning. Still morning. Good morning, everyone. I'm Rahimi. So yeah, first I would like to say thank you to the Federal Institute of Science and Technology, FISAT, for the invitation to have this session. And yeah, I was excited to be over there to present this session physically. So I already booked the ticket and everything. But a few days before the flight, I was starting to read what are the things that I can do when I'm over there. I start to read a bit, and then suddenly I go to one tab before you travel, and then before you travel, and then I click, says, oh, you need to apply for e-visa. I was like, oh no. And then during that day, it's already Sunday, and yeah, last Sunday, and then Monday, 2 days ago, it was a public holiday in Malaysia. It was our king's birthday, so there was no possibility for me to go to the embassy of India in Malaysia to request for, let's say, expedited visa. So yeah, so in the end, yeah, now I'm here online for having this session. So yeah, thank you once again to FISAT for the invitation, and I'm sorry could not come physically, and I hope maybe for the years after this I can come in person. Yeah, because I think I've been joining or my group have been joining this conference, I think 2 to 3 times. Yeah, it's a good conference. So I think it's a well managed, and it's very hard to do a conference, because this year, at the end of this year also, I'm trying to have our own conference. And yeah, we just started to do it. Yeah, and it's a lot of work and commitment. So yeah, congratulations to FISAT, especially yeah, the Department of Civil Engineering team. Okay, thank you. So I'm good. I don't know how we can interact, but I will share my slide, and then I will share my screen, and then I can go to part of the slides. But yeah, if there's any question or anything, feel free to ask from time to time. Just I want to reconfirm. Now I have how many minutes? Because I think there's a bit changes in the time for, so still maintain. Yeah. for the time?
Sir, 45 minutes would be perfect.
So that means I finish at what Indian IST what time, Mr. Jawahar?
About 12 Indian time.
12. So yeah, thank you.
45 minutes. 45 minutes.
Yeah, okay, thank you, Mr. Jawahar. Okay, so if that's the case, I'm going to share my slides. Okay, and also yeah, if there's any questions from the audience, I mean offline and also physically and also online, the ones in the Microsoft, the Google Meet, I can see if there's any text on the chat.
Sir, we will post it in the chat session. Once the session is over, sir.
Okay, yes, but yeah, if anything, yeah, can stop. Okay, so yeah, I'm going to share a bit on producing accurate digital twins of construction projects. So yeah, it's also one part of the I think what have been discussed about we civil engineers, we want to move towards more technology, advanced technology in construction. And also one of it, yeah, I think have been discussed by many of the delegates was building information modeling. And yeah, when I was in the US, yeah, it was building information modeling. But last year when I went to the UK to refresh what's been done by the other countries, they already start to go to digital twin. So when the FISAT team requests to give a talk about technologies in construction, I think digital twin can be one of it because it's one of the most latest one that we can discuss. Okay, so just time. Okay, so what is digital twin? Digital twin in general. Okay, so when we use the word twin, it means it's like a replica of us, right? For yeah, and for example, if we have a twin, but I don't have a twin. Let's say I have a twin. Yeah, that if that twin is the identical twin, yeah, it will be the same. Okay, and here digital twin, it means more of the digital replica of something that is physical. Okay, so if in the aviation industry, they have already been advanced with this digital twin, where they have the digital replica of the airplanes. So if there's and then they have sensors and everything. So if there's any issue with the plane, they can detect on the ground. Okay, so that's the idea. Yeah, so that means better monitoring of the airplane from the ground, and even in medical, there are some advancement. Let's say to put in our body there's a digital twin of our body. Okay, so that means how we can develop this digital twin. Okay, so we have a physical version and a twin version, a digital twin version. Of course, there will be need to have data which is a lot of data points. Yeah, because if there's only a few data points, it will be a very rough replica. But the more data points that we have on that physical version, the more accurate the digital twin, the twin, the digital twin of it. Okay, and then what we can use, just like the example of the airplane just now, we can use for monitoring, for analysis, for simulation, many things that we can do. Okay, and yeah, we'll go through bit by bit. Okay, let's say for the AECOO industry, architecture, engineering, construction, operation, and owner industry, it has been expanded. Okay, so it's if a digital twin of a building or a facility, it will be the digital replica of the building or facility. Okay, and then when we have that replica, we most of the time, if it's during operation and maintenance, we can use it to monitor the building. We can analyze the building for any issues, or we can do predictive maintenance because we can do simulation. Okay, because you have the replica. You want to do something, you try at the replica, your digital twin, and then if it's good, then you do that something. Okay, so for example, let's say you want to change the a simple one. Let's say the lights. Okay, so maybe before this, you want to, let's say a 50 watt, 50 watt LED light, and then you want to change to 25. Okay, so you can put into that, you can simulate to see how does it impact the energy, how does it impact the lighting of the building. So you can simulate, and do predictive maintenance, or any, most of it will be to decision. Okay. Okay, so maybe when I show the picture just now, maybe it feels like, oh, it's a model. So we have been discussing about BIM, building information modeling. I think just now several of the delegates said the word BIM, building information modeling, BIM. And so how does it differ between digital twin and BIM? Okay, so I mean if I'm physically over there, we can do like a session to see how many people think is how's the relationship. So one, the possibility, I think there's 4 possibilities. One, BIM is a subset of digital twin. Second, digital twin, DTO, is a subset of BIM. Third, BIM is digital twin. Fourth, BIM and digital twin is not related. Okay, so maybe which one is it? Okay, so we will discuss today bit by bit, and then if any questions, we please feel free to ask. Okay, so if it feels confusing, don't worry. Okay, it has been, and that's why we did a study. We did a study. What we did, we analyzed. We do a literature review of the papers, published papers related to digital twin and BIM. That means papers that use both words, digital twin and BIM, and see how they write the relationship between BIM and digital twin. Okay, and then this is what we found out. So in the end, we do some filtering and everything. From 55 articles, okay, 60% said BIM is a subset of digital twin. And then there are second, there's no relationship to BIM and digital twin. The BIM is digital twin, and the list is digital twin is the subset of BIM. Okay, and just to show you, it's confusing. So when we go even into articles, we check. So people give different definitions between BIM and digital twin. Okay, so let's go through it. Okay, so we go one step back. So what is BIM? So we can see the differences between digital twin and BIM. Digital twin just now is the digital replica of a physical building or facility. Okay, how about BIM? BIM is the process. The process that involves generating digital representation of something that we want to build. Okay, so for example, we want to build one of the building for FISAT. Okay, so before, normally we have drawings, right? We do all the drawings and everything, and then you construct at site. Okay, so instead, you develop the drawings and construct at site and found issues on the site. The idea of BIM is a process where you build, let's say, the building for FISAT just now, digitally, on the software. On a software digitally, you develop, you build it digitally. You clear all the problems related to that design. Once everything is okay, then you go to the construction phase. So that means it's a process that you build digitally first, then you build physically. Okay. So the point here, you see that BIM, you have the BIM before the construction phase, the best case scenario. On the other hand, it's now digital twin. You have the building already, for example, FISAT building, and then you have a digital version of it. The phases are different. Okay, so even before this, even when we see about the future of BIM, okay, how we can use BIM. Okay, just now, if you remember, BIM is the process to build digitally, okay, of the building. Okay, so when you have the you are building it digitally, you can do a lot of analysis too. Okay, you can develop from conceptual design, detailed design. You can analyze, do different analysis before you make your design decision. Okay, then you can develop drawings based on the model, and then you can use it for fabrication, prefabrication. Okay, modular construction, you can use it. And then you can do 4D, 5D. That means for quantity takeoff. You can also do for scheduling. Then you can plan your logistics, and then before this, when we talk about BIM, you can use the model for operation and maintenance. Okay, this is before we talk about digital twin. We talk about BIM. You have your BIM model. You can use it for operation and maintenance. Then you can use it. You can use for renovation. You can use for demolition. That means until the end of the life cycle of the building or facility. Okay, that's when we talk about BIM before this. Before digital twin came into the picture. So even BIM, we already start to talk about using BIM as part of the operation and maintenance. Then now comes another word, is digital twin. Okay. So, okay, how is it related? Okay, so in the end, the easiest way, if I can say in a layman way, the BIM is actually the basic level of digital twin. Okay, if you remember just now, you already have your model digitally. You design it during the design phase. Then you go to construction, you update, and then put into use for operation and maintenance. When you use for operation and maintenance, that would be the digital twin. Okay, but okay, let's consider that as the lowest level of digital twin. Because why? You only have a model, but the digital twin concept is that the highest level of concept is that it's automated. It have AI, machine learning, and everything. So from the model, how can you the base is the model, the let's say this left hand side. But then during the operation and maintenance, if you install all the different technologies, let's say sensors, you have sensors, then you will be you will be updated. That's a higher level. Okay. Not only if you have sensors and then you automate it, that means you use data integration, analytics, AI, everything. Then that will be the highest level of the digital twin. That means it's automated. Okay. Maybe the second level, the basic level is just you have the model. The after that is you have the sensors, but you still need your facility manager to make the decision. I need to do this, you need to do that, to switch on the aircon, to fix the lights, to call, let's say, the plumber. But if you have the AI version, the highest level of version, it is automated, and then the facility manager doesn't need to do any decision. It will just run by itself. Then the facility manager will just monitor. If necessary, then it will intervene. Okay. So that's how BIM and digital twin. Okay, so BIM is more during the design and construction phase. And when you pass to the operation and maintenance phase, it will be the lowest level. Then when you integrate with more technologies, then it will be the digital twin. Okay, so please don't be confused, as even inside the papers that we analyze, only 60% said BIM is the subset of digital twin. So yeah, it's okay. Okay, so yes, so yeah, just now we talked about BIM a bit and see we can use for a lot of things. So one of the main benefit is that if you build it digitally for BIM, then you will avoid any issues on site most of the time. Okay, so that's more BIM for the benefit during the construction phase, because we have several projects. What we did, because some projects they did not start with BIM. Okay, we just came as a consultant. We joined in, then the client gave us the drawings and everything. Then we just built the model it. Then what we found out, for example, the roof is not, the design of the roof is not proper if based on the structure of the roof. Okay, so it was for a hospital, and then so the client was it's a government the client is a government agency, said to the designer, to the contractor, ask the contractor, okay, have you ordered the material? Okay, so luckily during that time, have not ordered, right? So it's okay. But if it has been ordered and then when during construction, then we found out that the design of the roof is not suitable, then the government agency need to fork out more money for the design changes. Okay. So yeah, that's more for construction. We also have other examples. Let's say there was some design where the columns are not at the proper place. Okay. Okay. So how about digital twin? Okay. So I think you know about the benefits of BIM. Okay. Digital twin. When you have it for operation and maintenance, then you can have real time information interchange between your physical and also your digital version. Then there you can do condition monitoring, real-time diagnostics, predictive operation like we discussed just now. And also, I think one of the delegates talked about in the future. In the future, we will involve more related to demolition. Okay, okay. Yes, I mean we as civil engineers, or in the construction industry, okay, we will always be needed. So one of the delegates talk about the salary of civil engineers. Although we one of the oldest engineering discipline, and we always be needed. We always need buildings, infrastructures, roads, highways, bridges. Okay, okay. So if without this digital twin, okay, normally what would happen when we construct something? Let's say the bridges in the US, for example. Okay, most of them are old already. So what they need to do, they need to do a regular checkup. Checkup means they need to test whether the bridge is how's the structure right now. They will test the strength of the structure from time to time. Okay, based on the decided periodical time. Okay, and then based on that, then they will decide whether they need to demolish that bridge and build a new bridge, or we reinforce the structure of the bridge. Oh yeah, so that means what's happening is they do not know what's happening to the bridge real time. So if let's say one day the bridge collapse between the check-in, who will be at fault? But if using digital twin, where you monitor real time and you can know the strength of the bridge every day is real time, you can avoid any unnecessary disasters. So that's if we talk about infrastructure, where we can monitor our infrastructure in real time and can avoid any unnecessary complication. Okay, so one is building maintenance. Building maintenance. Second is about the infrastructure strength. So yeah, real time diagnostics, condition monitoring. Okay, so this is the concept. The concept of BIM, digital twin, is based on one of the reports by the European Horizon. Okay, that report, that report, they focus on what's the meaning of digital twin, and they want to define what's digital twin. So in this, if you read the report by the European Horizon, I think it's published last year or this year, they go through all the definitions, and then many definitions have been proposed. Then they also propose the relationship between BIM and also digital twin. Then finally, they propose this concept where BIM and digital twin, BIM is part of digital twin, and then it will be used in many activities of the AECOO industry. Okay, so yeah, I will not go through all of them. But it's not like we talk about facility management, then space management. You can even use it for security and safety. Why? Because it's real time. So that means if there's any breakage, any on the building, it can trigger the monitoring system. Okay. energy service. So in some parts of the world where they focus on, I think if we go to the UN SDG, energy is one thing that we try to optimize. Okay. So we just talked about our industry, but we also need to consider that this digital twin is also part of actually a bigger scope of our country. Okay, because it relates to the smart city. Because based on all the different digital twins that we have. Let's say you have the digital twin for your building, you have your digital twin for your power plant, you have your digital twin for your um, power lines. Okay? In the UK, they already start to develop digital twin for the power lines. Because why? They will use all those information to make, they call it system of systems. Okay, so one system, let's say uh, the energy system. Then there are also other systems, let's say just the normal buildings. So when you combine everything, we call systems of systems. Okay, and then all these systems of systems, when you integrate, will be part of the smart city movement. Okay, so it's a very big relationship between what we do and the outcome of our country or of the city. Okay, so you see, we start from BIM, and then that's that's digital twin, and then that digital twin will contribute to the smart city. Okay, so that's the we talk about how important is digital twin. Okay, but in the end, as like we discussed at the start, is the digital twin is based on data. So if we don't have accurate data, you put inaccurate data when you are developing the digital twin. Of course, you will develop inaccurate digital twins. And then when you have inaccurate digital twins, whatever simulation, whatever real-time monitoring, whatever analysis that you do, the output will also be inaccurate. Okay, so that's why the idea is we need to have accurate data, accurate digital twins. Okay, so whatever we do, it will be beneficial. Not just we do it and then it doesn't work out, just waste of our resources and time. Then also part of the resources. Okay. So we want to produce accurate digital twins. So how we can do it? Okay, to produce digital twin, basically there are two concepts to do it. Okay, one is based on the BIM that we see just now. It's on the BIM model. You update and everything you use for operation and maintenance. That will be the lowest level of digital twin, and then you update. The second option is you use reality capture technologies, for example, laser scanning. Okay, you laser scan. That means you scan whatever building or facility that you have. Then you will use the technology to create your model, your digital twin model. Okay, if let's say if you already, the building is like the building that you are sitting in right now. Okay, if we want to create the BIM model right now from the design phase, it's not possible. Why? Because you already have the building right now that you are sitting right now. So the option will always be reality capture technologies. Okay, so for that, how to produce accurate digital twin? Most of the time is you need to use a more, I can say, expensive or more advanced laser scanners. The more advanced, the more accurate your digital twin will be developed. And then most of the time there will be some cleanup processes to ensure that the laser scan model, the SBIM model created by the laser scan is accurate. There will be some checking process. Okay, so the laser scan is necessary if the building is already been constructed. Okay, but on the other hand, if you are constructing a new building and you start with beam, okay, what you want to do, you want to ensure that the beam model that you have will be used throughout the construction phase, updated accordingly. So when you pass to the operation and maintenance phase, it's accurate to be used. You don't want to pass inaccurate SBIT model from the construction phase, and then it cannot be used. And then what the owner needs to do is to do laser scanning one more time. And then that will be very costly to do. I mean, if it's already, the building is already there, it's okay. But if you start from a new building, you didn't do the process right, then you do another laser scanning, then it will be a lot of resources, a lot of money will be wasted there. Okay, so the way today for today's discussion, I want, let's say, for all of us to ponder, to think about. Okay, so yes, if we do construction, we use beam, we need to do it properly. So when we produce the SBIT model, it can be used for operation and maintenance. And there's no need to do laser scanning one more time. Okay, to have that ideology. Okay, so with that ideology, part of my research group, my research group, actually we focus more on this CIIRG. We have several academics, but for me, I focus more on decision making. Okay, so to move forward, yeah, there are some of our research that is going, that the target is to help to develop this accurate digital twins. Okay, so with this ideology, what we think the best that we can do is we want to always to try to improve the planning phase, right? So not the construction, right? During construction, if you want to change anything, I think I don't have to discuss this. We all know the opportunity is less. If you want to do any changes, it will be a lot of cost and everything. So whatever we do, we try to plan earlier, the better. Okay. So some of the research that we do, one, we want to improve some the organizational attributes or the company's capability in producing digital twin. Okay, because before this, our idea, not Malaysia, I mean, in general, in the construction industry, the idea is to generate good BIM models for the construction phase, but does not look into how to produce accurate models for operation and maintenance. So it's a common problem in most parts of the world, and yeah, so it's a phase that we go through. Okay, that we go through. Before this, we focus on BIM. Now we are starting to go to digital twin. So before this, we focus on increasing the company's BIM capability. Now we want to focus at the digital twin capability. Okay, so yeah, this one that we do. So this is just based on interviews. But yeah, we already go through with experts and everything. But yeah, the results have not been published. But the idea is you can find ways to improve the output of the SBIT model, SBIT model. So it's more suitable for the operation and maintenance. Okay. Okay, so that's about the organization. We improve the organizational capability. The second option is we check. Okay, there's a term here. Maybe some of you are already familiar. Is construction readiness. So that means construction readiness means that whether the project during the design phase, is it ready or not to go to the construction phase? Okay, because most owners, most parties, they want to go to the construction phase because that's where the money is. So they want to finish the design phase as soon as possible, go to the construction phase and reap the monetary benefits. But in the end, when we go too fast, then there will be a lot of issues. Okay, so what we do, we want to evaluate whether the design phase, what have been done, is it enough or not? If it's okay, then you go to the construction phase. Okay, so so this started in the US. They develop for industrial projects, and our team we do for highway projects, and then also now for BIM. Okay, so I think it's, explain this now. Okay. Okay, so what we found, I mean, based on what we have found many things, but some have not been published. So to protect the student, I cannot show. Okay, so there's challenges in the uh, design phase to make sure that the project is ready for the construction phase. Then when we involve projects with BIM, there are certain challenges that is related to BIM itself. Okay, so yeah, because lack of time, yeah, if want to know more, then you can try to read the papers. Okay, so but the idea here is that different types of projects, different with BIM, without BIM, the challenges, the assessment, all would be different. So that's why we need to develop. We need to check what's the criteria for different types of projects. Okay. Okay. So that's what we do for research. We also do different things also for research. Okay. So there are some of the students they focus on digital leadership. Digital leadership is now you have already the models, the digital version for construction, for operation and maintenance. But how you want to use it to achieve the project objective or the organization objective, that would be digital leadership. And then I think some other countries, for example, Singapore, Korea, few countries, they already go to the national BIM submission. And then we also doing research related to that. Because in the end, if we want to do BIM, want to do digital twin, want to do smart city, needs to be the whole industry. Okay, even for submission. Because if it's you do BIM but still submit as drawings, there will be but inefficient that. And then we also look into the hidden cost of technology. Okay, because last week there's a government agency, one of the state government agency came to have a discussion. Very simple question that they asked. Okay, if let's say they do BIM, how many percent will increase for the project cost? We don't have answer. Not I don't want to share, but we don't have the answer. Why? Because there's a lot of hidden costs. So that's why some of our students, they are doing research on the hidden costs related to new technology, including BIM. And then lastly, we also, we want to do well. One plan is part of the planning for BIM is BIM execution plan. Because there are also certain issues. Some projects they have certain issues because of the PEP, BIM execution plan. We also doing research on that. Okay. This is based on research, but we also want to look. I also want to share how we do nationally. Okay, so in Malaysia, what we do, we have a lot of plans. Now, actually, we are also developing a BIM roadmap for 2025 until 2030. Okay, because when we have a plan, then we can move towards it. Okay, so before this, there are many different plans. Okay, let's say the construction industry transformation plan, the housing plan, the plan by the public work department. Okay, but what we found out that actually BIM is not only about construction industry. It's actually it is more than that. That's why we civil engineers, we the built environment professionals, be proud of us. What we do is not only our industry; it's actually for the whole nation. So when we go into this the latest BIM roadmap plan that we are doing, we see it doesn't fit under the ministry that overviews the construction industry. We think it needs to be under the top ministry. Okay, so that's one of the lessons learned that we have done from 2011 until now. Okay, but also to do that, the government also need to have policies. Okay, for example, we have the national construction policy where they also include BIM as part of the targeted policy to improve the construction industry. Okay, and also based on our experience, we also develop training modules for BIM in Malaysia based on Malaysia's construction industry. Okay, mean, from one side, it's always okay to take all the software accreditation, software certificates. Okay, let's say from any software companies. Okay, but the issue that we found that software companies, the module is not specific to the local industry. So what we did, we did some pilot projects, and based on those pilot projects, we developed this UMPSA developed some modules, and then these modules are being used nationally to certify the BIM modelers, BIM coordinators, BIM managers. So that's one of the lessons learned too, where when we do nationally, we need to create personalized training module for the nation. Okay, so yeah, because India is a bit bigger than a lot bigger than Malaysia, so maybe if it's like the United States, then you can develop modules even for different states in India. Okay, and also it's part of our government plan is to do BIM for public projects 100%. So they let's say this is in 2020, where they say 50% of the federal projects, any projects by the federal government need to use BIM if they are more than 10 million. So it covers the different project delivery methods, but as part of the government policy. And also for public work departments in Malaysia, also they develop the guidelines, standards, requirements to ensure. This is to ensure, you remember just now digital twin, those model will be passed to the owner. Okay, and if the owner receive different types of digital twins, different design, formatting, and everything, it will be hard for the owner to use the BIM model, the SBIM model for the digital twin. Okay, so if you're a client, then it's the best is always to fit this guideline and standard. So whatever you receive will be based on what you want. Okay, so that's another thing nationally that we can do to move forward for digital twin. Even for highways in Malaysia, starting from 2 years ago, okay, we also developed the guideline for this and strategy for the Malaysia Highway Authority. So in Malaysia, it's compulsory for highways in Malaysia to use BIM for digital perfection. Okay, so yeah, we develop the different requirements, guidelines, standards for how to do BIM for the highways in Malaysia. Okay. Okay, so yeah, want to keep a few minutes for Q&A. So yeah, so in conclusion, so one BIM and digital twin is not the same. Okay, so and what we can consider most of the time, BIM is a subset of digital twin, and then we want to create accurate digital twins. If not, the output will be inaccurate. And then how we want to produce? One, we can always use laser scan. Want to make it more accurate, use a more advanced laser scan. But if you want to save cost, if you are having from a BIM model, you are doing BIM, you try to plan well. So the model that you develop will be accurate. So you don't need to do the laser scanning. And once again, and then in the end, so if besides, so if you do research, you can do related to improving the process. Normally there will be the people, process, technology. Technology is the much more most expensive and hardest to do. So that's for example from my side. Normally I focus on the people and the process. People also includes organization. And then finally, process will be also one, you can improve the process for the project, the organization, but in the end, it's the nation that need to move towards the BIM, digital twin, smart city, and everything. So I think that's all from my side. Within the time, so if any questions or anything, feel free to discuss with me. Have a bit of chat. Thank you. Anything, somebody speaking.
Hi, sir.
Yes.
Sir, we are opening the sessions for questions.
Yes, please.
Sir, there is one question posted in the chat.
Hello. Thank you very much for your nice presentation. It was so useful. As a researcher that I'm working on the same topic, digital twins, I have a question about the different phases of the construction industry. In which part you think we can, for the moment, we have the use cases.
Sorry, you are muted. I just can hear the use case, and then it's now mute.
From planning, I don't know, construction or maintenance, because I'm working in the same field, and I think we are really in the construction industry. We are really behind the other industries in terms of digital twins.
Yes, thank you for the question, but I'm sorry. Just now I could only hear the start and the end of the question because suddenly the system muted you.
I should repeat the question. Just my question was about the different phases of the construction industry. I mean, in which part do you think we could use digital twins in real cases? Because I think in the construction industry, we only talk about the theoretical point of view for the moment. We could have some real cases in the, as you mentioned, actually, in the field of energy efficiency in the buildings, which I have a PhD student as well that are working on. But I think in the field of the real construction, we are behind the other industries. Do you think it's correct, and in which part we can use digital twins more?
Okay, thank you for the question. I try to answer this one. Okay, so yes, okay, so there's two parts. One we can use there's BIM, the concept of BIM, and also even digital twin in construction. So that means BIM is more you do the process, you phase, and then you go into the construction phase, and then you build it, and then if anything you update it. Okay. But if you want to use digital twin during construction, okay, in practice, that means you need to keep on updating, and that's why But if you want to, let's say, you want to put sensors, you want to put technologies to keep updating the site to make sure that it's the digital replica of the construction site, digital twin of the construction site. The issue most of the time will be cost. Okay, because if let's say you want to put monitors just to sensors to monitor the progress, after you finish the project, you will need to remove those technologies because it's not part of the building, for example. So if that's the case, unless I mean depends from country to country. So in Malaysia, we tried once, but in the end, yeah, we do the what we did is actually we use the laser scanning for monitoring. But that's also costly because let's say if we want to use the laser scan for one time, two times, every once a week or every day, we cost something. And until now, I mean, in our industry, we still they don't think that there's such a need to digital twin for the construction phase. But digital twin during the operation and maintenance, that we can use. So because it's more um, more structured, where whatever sensors that you put will be used, let's say for 10, 20 years. So the return of investment is there. So to answer the question short, so if digital twin, normally it's much more suitable for the operation and maintenance phase, and then the B, more during the design and also the construction phase. So I hope that would be my thoughts based on the recent discussions and everything. Yeah, thank you. Hope that answers.
So one more question. What issue is there in the scope of digital twins implementation in Malaysia and its replicability that you spoke about towards the end?
Sure.
Issue of scope of digital twins in implementation in Malaysia.
The scope. Okay. So what did I say in the end? Yeah. But yeah. Yeah. Okay. So actually, I don't quite understand the question. But if let's say, if issue related to digital twin in Malaysia, if let's say one, okay, the example just now, we already mandated for our public projects. Some of our public projects need to use BIM. Okay, so at the end, when the project is finished, they will pass the SBIM model for operation and maintenance. Okay, one of the most simple issue is that the model does not really represent the physical project and the physical building. Okay, so that's one issue. The second issue, yeah, still the same issue, does not represent because it's not being updated. The second issue is not accurate. Okay, so the model when the owner receive it, some even there are when we check there are some of the even let's say lighting on the highway is flying. So how can we use that for operation and maintenance? Okay, so that means one, insufficient information. Second, inaccurate information. Okay, the third one, just as let's say we talk about three points. Even if everything is there, everything is okay, but how to use it efficiently to achieve what the organization wants to do with that SBIM model, that's also another issue. So that's why when we move forward right now, we go to the digital leadership. Okay, that means we already have the SBIM model, but how we want to use it efficiently for operation and maintenance, that would be another gap right now. Okay.
Thank you, Dr. Rahimi. Any more discussions? Okay. Thank you, sir, for being here because it was not possible for you to come over here physically, as you have explained, due to some visa problems. However, you have made it possible to be with us till 12 o'clock from 9:15 a.m. Thank you for being with us. And you have shared the current scenario, what is happening in Malaysia, and the contribution of UMPSA towards BIM regulations. All these things were very useful to us because we are just beginning the possibilities or exploring the possibilities of having digital twins in this construction area. Your session was truly fruitful for us to understand the scenarios there over Malaysia. Thank you very much, sir, for being with us, and thank you for all your contributions to make SECON'24 a grand success. Thank you.
Yeah, thank you, Dr. Kavida. Yeah, so yeah, thank you. If anything, also can contact me. Can link in. The same. My name Rahimi A. Rahman. Can contact me if anything. Okay, thank you. Thank you very much.
Thank you, sir.
Now, I would like to welcome Dr. Anand KS, who holds the position of Assistant Professor in the Department of Civil Engineering at SRM Institute of Science and Technology, Kattankulathur, India. He earned his Bachelor of Engineering degree in Civil Engineering from Annamalai University in 2004, followed by a Master of Engineering with a specialization in construction engineering and management from the same university in 2006. During the interim period, he gained his experience in various construction organizations as a planning engineer with a focus on project management. Serving as a faculty member at SRM University since 2010, he successfully completed his PhD construction management, focusing on construction personnel management. His areas of interest for research and teaching are health and safety, organizational culture, productivity, well-being in construction management, quality of work in construction, lean practices, human resource management, green buildings, management concepts for civil engineers. He is a lifetime member of numerous professional associations related to construction and civil engineering. Sir, I welcome you.
Morning, everyone. Am I audible? Yes, very good morning. And as already everyone introduced about me, I'm Dr. K.S. Anand from SRM IST, Department of Civil Engineering, Kattankulathur. And before starting up my presentation, I thank HOD FISAT Civil Department for this great opportunity. And also I thank the SECON team for this great opportunity. And also I'm the person who always does the research or the work in personal management, that is human factors in construction. But based on the team and also Mr. Jauhar insisted me to do in something related to digitalization. So I did my research in this particular area. Even this study or this presentation is about the exploration of the basic study of AI and ML incorporation in construction research. Next slide. Slides, please. The topic is the building the future, AI and ML revolution in construction research. Next. Okay. So everyone knows about artificial intelligence and machine learning. What is happening right now, and which is very new to our construction industry. So even now, people started working in construction research, or maybe even construction industry. People have started working in AI and ML, and specifically focusing on enhancing the efficiency, safety, and innovation in construction. Even all the phases of construction, like starting from your pre-phase construction phase, and also the post-construction phases. Mainly, the role of AI and ML in constructions are varying, and specifically artificial intelligence involves in development of computer system which performs typically requiring the human intelligence such as visual perception, speech deduction or recognition, decision making process, or even the language translation. This is specifically used in construction sector, and also the machine learning, which is the subset Okay, thanks. The machine learning is a subset of your artificial intelligence that also runs a more algorithm, or the large number of data set can be utilized for the furthermore deductions or predictions of your exploitation programming. Starting with generative design in construction. The generative design is a revolutionary approach in the construction industry, leveraging the machine learning and artificial intelligence for giving up a proper optimization and innovative solutions for betterment of the any kind of challenging environment. And this technology allows both the engineers or architects or the professionals who is working in industry for enabling the creating high efficient, sustainable and aesthetic pleasing structure. The main process of this is the 4 steps which is involved: the input, generation, evaluation, and selection. That is the input, which is we are defining the specific goals or objective for this specific project, which can be used any kind of material usage or cost control or aesthetic view, performance, and any kind of constructions or any kind of demands which is there in the site. Okay, so we have to give the input, then the algorithm will explore the more number of possible potential solutions for it. Okay, so any kind of different solutions can be there. So with that, we have to evaluate, and each design can be evaluated against the particular specific objective of our research or maybe your particular task. And with that, we can select particular optimal design can be selected for the proceeding further level. And the application of the GD, that is generative design in constructions, or in the various design, which is like maybe starting from your architectural design, structural engineering design, facade design, urban planning, material optimization or material usage, space planning. Okay, so these are the different areas we can cover with generative design. And specifically when it comes to the architectural design, like maybe different generative designs can be create for the complex structures, or both appearance and also the structural point of view. And also for structural engineering specifically comes for the load distribution, and for space planning, for utilization of all the layouts. All the layouts can be used with this GD. And facade design, that is also comes under the aesthetic and functional views. And urban planning, this is for, again, it comes under the space planning. Then material usage of specific optimal usage of any kind of materials. Maybe we can reduce the waste also. Then comes under the building information modeling also comes here, which is as the earlier session covered by my friend Rahimi. It's all about the digital BIM and the digital twin integration. And even this also comes here in your AI and ML integration, which is it's a representation of both the physical and functional characteristics of facility. It serves a better knowledge or shared knowledge resource for information for facility, forming a reliable basis decision during its life cycle process and inception onwards. Here, 3 main things which I wanted to specify here, which is design visualization, because it provides 3D visualization that can gives better understanding of the real-time project, and also for communication purpose we can use this, and collaboration, which enhance the collaboration among the people who is involved in the construction, like architects or engineers, any kind of contractors or stakeholders which involved in it. Then life cycle assessment or management, supports the entire life cycle process, building from design and construction to operation and maintenance process. Then enhancing the BIM with AI. Okay, here this I can say this three different particular phases, which is real-time data analysis, predictive maintenance, and automatic class detection. Okay. These all, even the BIM also can do it, but still the further artificial intelligence algorithm can collect the more number of data and analysis the real-time data from the construction site or construction projects. There we can find out some better insights or provide actionable insights for the improved decision making and project management decisions, and efficiency, which is enhance the efficiency to identify the patterns and trend that may not be immediately apparent. And predictive maintenance, anticipating the failures. The AI can predict the failures for potential equipment or structural failures before they occur. And maintenance scheduling, even optimizing the timeline, that is very much important in construction duration. And also it should be economic in the sense that can reduce the maintenance costs and improve the resource allocation. And finally, the automated class detection. The class detection also can be done in BIM also, but specifically the AI tool can be used for any kind of like any class detection with different building system, which is HVAC, electrical plumbing, and in the BIM model. And this can provide suggestions for resolving the detected classes and ensuring the smoother construction process. Risk mitigation, minimize the risk of costly rework and delay during construction. Here it's clearly mentioned in that website, like I noticed in some website that uploaded in Notify, which is digital strategy for AI and BIM integration. Here it's very clear that enabling is the particular thing, which is education, incentives, and data. That is there the main process starting. Then comes under your risk management standards and responsibility, that is governing process. Then designing comes under design, sustainability, and automation. All these three will integrate together for better solutions for construction. And AI enhanced BIM tools, and there are three things which we identified through some various sources, which is the Autodesk BIM 360 and Rivetso and smart videos. That everything has its own like usage, which is BIM Autodesk. Already everyone will be familiar with that. That is for identifying the risk and suggest some corrective actions, all those things. Then the Rivetso, it integrates the AI real-time class detection and collaboration against the project teams. And smart video is which visualization data of construction site for specifically safety and quality control. This can give the predictive any kind of issues which is there in the construction site, and that can improve the project outcome, which is the performance and the productivity will be getting increased through this specific tools can be utilized in the site. And also it enhances the safety to identify the safety hazards in advance, helping to create a safer work environment. And future prospects, there are continuous improvement will be there if you are collaborating or combining AI and BIM technologies, or continuously evolving, offer new capability and efficiency. Then wider adoption, this as of now it started implementing everywhere, this particular all these three tools. And towards sustainability, this will help for promoting the sustainability in construction industry. The project scheduling in construction management, specifically scheduling is a major like a demanding thing which is prevailing in construction site or project. So for that, maintaining the proper time and the resource allocation, this AI tool will be efficiently utilized. And specifically coming to the resource allocation, this ensures the efficient allocation and utilization of the resources. Resources all comes under your material, men, and your machineries. Then timeline, it helps to manage the timelines to meet project deadlines. Cost control, of course, cost control is very much important for a construction project, because more number of money involved in this particular any kind of projects. Then coordination, coordination are the important thing because many people are involved in this particular projects. So people management is highly needed. For that also we can utilize this kind of like the AI tools. And for analyzing the hierarchical data, which is the earlier data what we are having, we can use the machine learning for using the algorithm. We can analysis the historical project data to identify the patterns and the trends. Okay, what kind of systems they used or they adapted previously, that can helpful to look further rectification for the any kind of future works. Okay, then benchmarking, for that we can have that data for the benchmarking or like using that as a benchmarking tool. Then predictive delay identification also can be identified or using this kind of ML modeling, maybe any kind of weather conditions or environmental conditions, supply chain issues or labor availability or any kind of resource lacking, right? Material, all these things will be comes under there. Then proactive measures enable the project managers to take a proactive measures to mitigate risk and avoid delays. This is very, very important in the predictive delays. And the benefits of using this ML in project scheduling is enhance the accuracy. Accuracy is very important in our thing because maybe we may miss because of negligence or by mistake we may missed it certain data. So with that we can have this as a data bench, a data set, and we can use for any kind of future utilization. And dynamic adjustments, the continuously update and adjust the schedule based on the real-time data and the project progress. And resource optimization, resource in the sense all kind of resources like even machineries, men, and your materials, everything comes under that. The resource will be specifically, we can say have the data so that we can track it. Then specifically coming to the next important topic, which is automated inspection in construction site, quality control and safety. Okay, the automated inspection in constructions involved using advanced technologies such as drones, robots, and AI to monitor the assess the quality and the progress of construction activities without human intervention. So this is also needed. Importance is the efficiency. Efficiency is the streamline the inspection process, allowing the faster and more frequent assessment. Then accuracy, reduce human errors, ensure precise and reliable inspection results. Safety, minimize the need of human inspectors in hazardous area and enhancing the overall site safety. Cost effectiveness, the lower inspection cost by reducing the labor requirement and improving the defect detection early in the process. These are the 4 important things can be added. But when coming to the safety, I clearly says that more than any kind of tools or anything, the human notification is very much needed. So specifically only that point I can change here. All the other can be utilized very much in using AI. And then technologies and the benefits which is used for automated inspections, drones. Everyone knows now the drones are widely used for site inspection. So equipped high resolution cameras and sensors to capture the aerial images and the data of the construction site. It is used for surveying, mapping, and monitoring the site progress. Is there anything is happening in the particular site? So we can also see that for proper inspection. Then robots, I don't know, Indian strategy, it take much more time to utilize the robots in construction site, but still mobile robots with the cameras and sensors can navigate the construction site for capturing the detailed data and structural components and finishes. And the application is the idea to inspect the hard to reach areas, which is not the specifically we can focus the all structural elements also, such to tall structures and or any kind of confined space. Then AI algorithm analysis the data collected from the drones or by drones and the robots to identify the defects, deviations from plan, or any kind of potential safety hazards. The application, the real-time analysis and reporting predictive maintenance and quality control. And also the safety monitoring in the construction research using AI and ML. The safety monitoring in the construction involves the continuous observation and analysis of the site conditions or real-time site situation for any kind of construction projects, and the worker behavior to prevent accidents and to ensure the compliance with the safety standards. Okay, both the site conditions and the human observation also can be done using AI and ML. And again, as the same thing here, the accident can be prevention. The accidents can be prevented using this thing, and the compliance to ensure the adherence to safety regulations and standards based on the nation. Every nation has their own standards and this thing. So based on that, we can generate, and the worker protection or the people who is involved in the construction project can be, like using this can be in the safe monitoring specific area. And also the cost reduction, reduce the costs associated with the workplace accidents, including the medical expense and the legal liabilities. These are very important things for the safety monitoring. And coming to the computer vision, wearable technology, and predictive analysis, these three can be used for the safety purpose. And the computer vision, use the cameras and the AI algorithm to monitor the site conditions and the workers' activities. The real-time ergonomics condition can be identified. Unsafe behavior, or such as not wearing any kind of PPE, and the monitor for the trip and fall hazards. These are the major things for the computer vision. Then wearable technology, equipped with sensors tracking the workers' movement, vital signage or signs, and the environmental conditions can be detected using this wearable technology. This can alert the workers or the supervisors to potential health risk, such as exposure to harmful gases or excessive physical exertion. Predictive analysis, this ML algorithm analyzes the historical data and the real-time data to predict the potential safety incident. For that, by using that data, we can use for the next future any kind of preventing any kind of accidents or thing. Then benefit, it is real-time hazard reduction can be done, and enhanced risk assessment can be, the ML model can analyze large data set to assess the risk levels and predict future hazards, and improved compliance, which is general detailed safety reports and the compliance documentation can be done automatically using this ML. And this ensures ongoing adherence to safety standards and regulation using proper human interface. And predictive maintenance in construction site using AI. This is PDM, and now it's widely used everywhere. This data, it's a proactive approach that uses data analysis tools and technology to predict when the equipment failure might occur, or allowing the maintenance to be performed just in time to prevent unexpected breakdowns. Okay, specifically this can be done. It's a higher level of research is going on, but still it's in the budding stage in India. The main importance, again, I'm saying that equipment reliability, cost efficiency, safety, and the project deadlines can be monitored properly to help to ensure the proper everything is operative properly. Then the same thing, the data collection, as I said, sensors and IoT device is used in this specific area. The attached sensor to construction equipment to collect the real-time data on performance metrics such as vibration, temperature, pressure, and usage, any kind of patterns. Okay. Big data analytics, AI algorithm process and analysis large volume of data to identify the patterns and anomalies that can be identified potential failures. Then predictive models, machine learning algorithm, train the historical data and the real-time data to recognize the signs of impending equipment failures. Then real-time monitoring is there, continuously monitoring the equipment conditions to prevent the real-time predictions and alert for potential issues. Maintenance scheduling, the optimized schedule, the timeline is focused here. The challenges in AI and ML in construction research is getting the data itself. It's a big task because being a civil engineer, we are unaware of using any kind of tools or any data. That is really challenging one. So, and getting the data from the industry also, it's a very toughest task. So that is a major thing here. So the data collection is highly challenging. And moreover, we won't get the full data set, like maybe incomplete data or null data will be there. So utilizing that is also, we won't get the proper results. Then data integration, as people are aware of the BIM, IoT device, any kind of project management tools, even that is also can be complexing and challenging. And skills and gaps, there are more training is needed, specifically lack of experience. Again, in construction industry, like it's very tough to get this kind of artificial intelligence or machine learning, coding. These are very, we are unfamiliar with that. So we have to equip ourselves and upgrade in this particular thing. So lack of expertise also it's needed. So more number of training is needed. Then high initial cost, specifically this for this utilization of any kind of equipments or high level of this thing will be technology cost will be much more, and ROI concern also is much more. The construction companies may have highly like it is hesitant to invest in this AI and ML without clear immediate returns of on investments. And the maintenance and upgrade, ongoing cost, scalability, these two things is major thing. And maintaining and upgrading AI and ML system requires ongoing investment in the technology and personals. Individual also it will be a high thing. Then ethical and regulatory concern. This is data privacy. Even the construction industry, like it's like people who like there are privacy are there. There will be a sensitive information will be there, or any kind of complaints issues also will be there. So that is also a major challenging, which is ethical and regulatory thing. Then bias and fairness, algorithm bias. AI and ML models can introduce much more. Maybe sometimes it may bias also, so leading to unfair and suboptimal outcomes. So that we have to be so cautious. Transparency, ensuring the transparency is how AI decisions are made in a critical and gaining trust, acceptable from stakeholders. That is also there. All level people are not accepting this kind of thing. So that is a major challenge. Then future aspects of AI and ML in construction research. It is fully automated construction sites. Maybe chances are there in future, AI-driven robotics or autonomous drones and vehicles. This will be utilized in future. Maybe somewhere in people will be there and they will be operating from somewhere. Remote access will be there. Then intelligent machineries, self-learning equipment, machineries that uses AI to learn its environmental and optimize the performance over time, adapting different tasks and conditions. Collaborative robots, that is cobots. Even now people are using that for any kind of research, even the soft studies, which is even the contracts, that is also used. Then digital twin technology, as Rahimi sir already explained vastly about it. So this will be upcoming future thing. Overall, I said about the AI and ML, but now coming to the main picture, which is the human factor in the construction industry amidst the AI and ML integration. Because being people working in human factors, specifically, this will be a major thing I have to specify here. Expertise and decision making, the human judgment. Despite the precision of AI and ML, human judgment is crucial for interpreting the complex and the nuisance situation that machines may not be fully understand, right? So I really thinking this human evaluation, human factors evaluation is highly appreciated while doing any kind of generative models. Okay, so that is there, and even the experienced professionals provides insight and context that are vital for making any kind of informed decisions, especially unforeseen circumstances. Okay, so we have to get the decision like opinions from the expertise also. The experienced peoples are much more because those people, experienced people, or the people who is involved in the construction might know better than the machines. So I'm encouraging this also. And adaptability and creativity, problem solving. Human creativity and the problem solving abilities are essential for addressing unique challenges and innovation, new solution. Adaptability, that is human can quickly adapt to the changing conditions, on the construction site, whereas AI systems may require time to reconsider certain things, recalibrate. And communication and collaboration, the term coordination, which is the team coordination, which is effective team coordination and collaborating among the construction teams are essential for the project success. So human factors plays very vital role or significant role ensuring that all the stakeholders are aligned and informed properly about the AI and ML usage. The client interaction, engaging with the client and understanding their needs, feedback requires empathy and interpersonal skills that AI currently lacks. It's somewhere lacking. And ethical and safety consideration, as I earlier discussed, the ethical oversights. The human oversight is necessary to ensure that ethical usage of AI and ML, particularly in areas such as any kind of privacy or bias or fairness. Okay. Then safety supervision, while AI can predict and mitigate risk, human supervisions are essentially for maintaining safety standards and responding to emergencies. For this, overcoming this, the training and development is needed. Even in the institution like us also can give this kind of basic trainings for the people to utilize how optimal we can use that for the usage in the construction site. And upskilling for workers or the even professionals also, we need a training and development. Then the human machine collaboration training program should be focused on enhancing the collaboration between the human and machine, leveraging the strength of both. And integrative project management, this everyone is nowadays people started doing, which is hybrid management models and real-time feedback. Ethical, again, I'm saying specifically because AI implementation, we need a proper developing the guidelines for setting up the standards and the regulation for usage of this kind of AL and ML usage. And human oversight, continuous human oversight is necessary to monitor AI system and ensure they operate within ethical and legal boundaries. Finally, the integration of AI and ML in the construction industry does not diminish the importance of the human factors. Instead, it highlights a need for the balanced approach that leverage both technological advancements and human expertise. By fostering collaboration between the human and machine, the construction industry can achieve new levels of efficiency, safety, and innovation. Thank you. And I take this opportunity to thank head of the department of FISAT and all the faculty and all the team for the SECON team for giving me this opportunity. And also I thank my research scholar Soundarya to prepare this particular site for me to helping out for this presentation. Thank you. Thank you. Any queries? This exploratory level, so that this is very base thing. We didn't did much more research in this particular area. We started exploring computer vision in our institute and BIM, digital twins. We have started doing, but all the other things, algorithm and all, we are started doing it now.
Thank you. We are in the first level,
Okay.
as I asked the previous doctor that talked about digital twins. I think we are in the modeling part, maybe 3D modeling,
Yeah.
and for the construction, BIM modeling, and this is I mean, we are in the beginning of
Yeah.
the digital twins.
Yes.
So it is just a theory. That's why I'm searching for if someone really work on that.
Okay.
As I know, it is mostly about the energy efficiency that they
Yeah.
work on, and the part that we have real sensors that are working so well. So
Yes.
I think this is it.
Yeah,
Thank
we do
you.
have one of our colleague. She worked in also the scheduling part. Okay, they started doing generative thing AI and
I will
that.
I will be thankful if you can share the contact.
Yeah,
with me.
I'll share with you.
Thank you very much.
Yeah,
it was so good. It was very useful.
Okay,
Thank you.
Thank you. And also I welcome like everyone to SRM, and also please kindly, I'm not having my LinkedIn profile here. Just check it at my name and add with me, and if we can do any kind of good collaboration in future. Yes.
Yeah, thank you, sir. Thank you, Anand sir, for a great presentation about the incorporation of BIM and AI. And also the finest part, which I found very interesting, was the human importance. Whatever the technology improves, we all need humans to carry it for the future need. So that is where we lie, and we have the scope in the future also. So thank you, sir, for giving that much importance for the human factor, and giving us the hope that we always exist, whatever the technology comes. So thank you for listening to the presentations very carefully and asking the questions also. So we'll have a break now, and we'll resume back at 1:30 after lunch. And the lunch is for the students. It is being arranged in the above one hall is there, so, seminar hall, civil department seminar hall, and the guest will be accompanied by our staffs. So thank you. Please come back at 1:30. Thank you.
Hello, am I audible? Hello? Hello? हाँ हाँ जीतू यार
Hello, Vasudev sir. Hello. Hello.
Hello.
Sir, could you see the screen? Could you see
Yes,
the
yes. You can go ahead,
Okay.
please.
Okay, okay. Thank you.
Good afternoon, one and all. I welcome you all to the first session of paper presentation of the International Conference on Structural Engineering and Construction Management, SECON'24. I'm Alan Mira A, MTech student FISAT. We, Alan Mira A and Margaret Tenney, will be the student moderator for the session and will be available for any queries or doubts throughout the session. The panel for the session consists of Dr. Vasudev R, who is the Chair 1, and Dr. Asha Joseph as Chair 2. The session will have 4 oral presentations on paper IDs 34, 428, 434, and 430. We expect all participants to be present till the end of the session. Now, I welcome Ms. Margaret Tenney to introduce the session chair, Dr. Vasudev R, and Dr. Asha Joseph.
Dr. Vasudev R, currently working as Associate Professor and Head of Department at Turkish Institute of Science and Technology. He has done his Bachelor in Civil Engineering from Sri Krishna College of Engineering, Coimbatore, and MTech in Computer Aided Structural Engineering from Mar Athanasius College of Engineering, Kodamangalam in 2006, securing first rank. He pursued his PhD from Anna University, Chennai in 2015. His thesis was on investigation on behavior of turned steel scrap fiber reinforced concrete. His research interests include fiber reinforced concrete, repair and rehabilitation of structures, forensics in civil engineering, lightweight concrete, high performance concrete, and special concrete. In addition to his domain expertise, he has coordinated various FTPs and workshop on advanced concrete technology and sustainable waste management and have delivered talks on forensics in civil engineering. He has published more than 20 papers in various national and international journals and conferences, including American Journal of Engineering Research, International Journal of Scientific and Engineering Research, and many more. He has also received patents from Intellectual Property Rights, Government of India. Our section co-chair is Dr. Asha Joseph, currently Associate Professor at Department of Civil Engineering, FISAT. She completed her BTech in Civil Engineering with honors from Government Engineering College, Thrissur in 1997 and did her Masters in Computer Aided Structural Engineering from Mar Athanasius College of Engineering, Kodamangalam with first rank in 2007. Dr. Asha Joseph secured PhD on the topic Dynamic Behavior of Ground-Supported Cylindrical Water Tanks from Cochin University of Science and Technology in 2019. Dr. Asha started her teaching career as a lecturer at St. Kitts College of Engineering and later worked as an assistant professor in IES College of Engineering. She joined FISAT in 2014. Her areas of interest are structural dynamics, finite element analysis, earthquake engineering, and building information modeling. Being an approved research guide of APJ Abdul Kalam Technological University, she is guiding research project and acts as a doctoral committee member of research scholars. She has published 15 papers in journals and 20 papers in national and international conferences. She is the editor of the book Lecture Notes in Civil Engineering published by Springer. She is a chartered engineer and life member of professional bodies Indian Society for Technical Education and Institution of Engineers, India.
There are certain general instructions that need to be followed during the session. The presentation time is 10 minutes, followed by a 5-minute interactive session. There will be a warning bell at the end of 8 minutes. On the completion of 8 minutes, please move to your conclusions. During the presentation, all other participants are requested to mute your audio and do not interrupt the session and do not start the session unless you are prompted to. All are requested to attend the complete session. Now I invite our first participant on paper ID 34. Good afternoon. Good afternoon, all. My paper ID is 34. Accessing the critical success factors influencing the efficiency of existing health and safety practices in the construction industry of Kochi. So, moving on to the introduction, the construction industry is a hazard-prone industry in which both fatal and non-fatal injuries occurs. These not only causes horrible human disaster but also causes economic losses. These financial losses are due to the impact of accidents and damages on the plant equipment and workers. Moreover, there is also a loss of productive work time. And these accident, environment hazards and inadequate safety protocol are issues that demand urgent attention. And to ensure a safer working environment and promote sustainable construction practices, it is essential to review the existing health and safety practices. So moving on to the objectives are to identify the key parameters that influence the effectiveness of health and safety policies in Kerala and to evaluate the existing health and safety practices in Cochin construction sector through critical success factors. So moving on to the methodology, first an extensive literature review is done to identify the parameters that are relevant to the construction industry in Kerala. Then the stakeholders are identified and then we prepare the questionnaires using the identified parameters. And then evaluation is done for the factors in SPSS software to obtain critical success factors. The parameters identified were emergency response planning, workplace design, personal protective equipment, collaboration with safety professionals, subcontractor safety, risk assessment, stakeholder collaboration, budget allocation for safety, public safety measures, supervision and enforcement, safety records and documents, contractual safety requirements, compliance monitoring and reporting, and then safety audits, safety performance matrices, then environment impact assessment, traffic management, health and safety committees, then safety technology integration, workers involvement, incident reporting system, safety training programs, safety incentives, safety equipment maintenance, and health monitoring. So the study area includes Ernakulam Corporation and the 30 municipalities. And the 30 municipalities are of North Paravur, Pirava, Muattura, Kutatulam, Perumbavoor, Alua, Angamali, Tripunthara, Kalamassery, Kodamangalam, Elur, Maradu, and Trikakara. So the stakeholders that we are identified are construction laborers, design and site engineers, contractors, safety officers, insurance representatives, and project managers. So the questionnaire is formed for each of the stakeholders, and I have created 6 questionnaires, and the questionnaire is based on Likert scale 5 ordinal measures, in which 1 point is for strongly disagree, 2 for disagree, 3 for neutral, 4 for agree, and 5 for strongly agree. I have collected over 130 responses, and in that 130 responses, I have collected 21 responses from contractors, 21 from safety officers, 21 from insurance representatives, and 24 from construction laborers, 25 from design and site engineers, and 18 of them from project managers. And about 90% of them have more than 5 years experience in their field. Moving on to the first parameter, emergency response plan. From the survey, I have identified that about 90% of them agree that the construction site have a well communicated and well understood emergency response plan. And the next one is workplace design. In this, I have collected 67 responses, and majority of them believe that the design effectively promotes safety, efficiency, and minimize hazards. Only a minority disagree with this. And the next one is personal protective equipment. In this, a high level of agreement was found that it indicates that there is likely a well-established and recognized practices within the industries. And however, there is a presence of neutral responses about 21 and a disagreeing response around 10. That indicates that there might be still a room for improvement. And the next one is collaboration with the safety professionals. In this parameter also, about 75% of the responses have suggested that the construction project team believes that there is a proactive collaboration with the safety professional to ensure the health and safety practices. And next one is subcontractor safety. In this also, about 50% also agree that the safety protocols and practices are adequate as in current situations. And the next one is risk assessment. In this, about 70% also agree that there is in-depth and efficient risk assessment that are carried out during the construction projects. And we can see that about 20% of neutral responses, which indicate they have enough experience to give a strong opinion on the effectiveness of risk assessment. And also we can see a 9.4% of disagreement to this statement that in-depth and effective risk assessment that carried out for the construction project that you are involved in. And the next one is effective collaboration between all the stakeholders. In this parameter also, we have found that 69% of the responses say that there is effective collaboration between all the stakeholders to ensure safe working environment. So the next one is budget allocation for safety. In this parameter, I have found that about 70% of the responses agreed that the construction company invests a sufficient amount to guarantee safety and well-being of the workers at the construction site. And the next one is public safety measures. In this, about 69% of the responses was turned out to be positive, which indicates that they believe that the construction site effectively implements public safety measures to protect people in the surrounding areas of the construction sites. And the next one is safety rules and supervision and enforcement. In this also, about 67% of the responses were positive, which suggests that the most of the workers feel that safety protocols are generally well enforced on the construction site they work on. And the next one is safety record and documentation. In this about 66% have agreed that the safety records and documentation are readily available and accurate and up to date. And next one is contractual safety requirements. This also turned out to be a positive response. And monitoring and reporting. In this, we can see that 39 out of 60 response turned out to be positive, seeing as it as effective and efficient. And the next one was safety audits. This also turned out to be a positive parameter. And then next one is safety performance matrices. This also more than 50% have responded positively. And the next one was environmental impact assessment. In this also more than 60% have agreed that the environmental impact assessment are thoroughly considered during the implementation of construction projects. And in traffic management, we can see nearly a half of responses either disagree or give a neutral response, suggesting that there is room for further evaluation and enhancement of these measures, of the traffic management measures. And the next one is health and safety committees. In this, we can say that about 46.66% of responses agree or strongly agree that the health and safety committees are effective in promoting safety, and a significant proportion says that it gives a neutral response, and a smaller group gives a response of 21.6 and says that they disagree to the parameter that the health and safety committees are effective in promoting the workplace safety. And the next. You are allowed to time is due. Please conclude your presentation. Okay, and by then I have done an analysis in the SPSS software, and from the descriptive analysis I have found all the means of the parameters, and from that I have found the means of the means, and that turned out to be 3.43, and every parameter that having mean value more than 3.43 is considered as major critical factors. And
Now you can move on to conclusion.
okay. And it is found out, I have found 16 critical success factors, and moving on to the conclusion, an extensive assessment of health and safety practices in the construction industry was carried out, and found out various parameters influencing the health and safety practices, and then among the 25 parameters, 16 were identified to be critical success. 16 were identified to be critical success factors from with the help of SPSS software. The first one is emergency response planning, second one is workplace design, third one is personal protective equipment, fourth one is collaboration with safety professional, fifth one is subcontractor safety, sixth one is risk assessment, seventh one is stakeholder collaboration, eighth one is budget allocation for safety, ninth one is public safety measures, 10th one is supervision and enforcement, 10th one is safety record and documents, 12th one is contractual safety requirements, third one is compliance monitoring and reporting, 14th one is safety audits, 15th one is safety performance matrices, and the last one is environmental impact assessment. By considering the critical success factor, a framework recommendations can be prepared and observation can be developed from the remaining factors influencing the health and safety practices in Kerala. The purpose of the paper is to assist the authorities to achieving a safer and healthier work environment. Thank you. These are the references. Now the session is open for the interaction. Now we are handling the session to our chairs. Sir, we kindly request you to take over the session.
Yeah, Namaste. Thank you, ma'am. And I just say you a few words about the presentation. Like, what exactly you want to communicate is not been really reached because you elaborately explained about the factors in the initial stage. So my question is how you are integrating all these factors into your analysis. Now, individually it stands, right? How you are going to integrate this all?
Hello. Hello.
Hello, am I audible to you?
Yes, yes.
Yeah, you have individually, you have come up with many factors.
Yes.
So how we are going to integrate this? Yeah, how we are going to integrate this with considering major scenarios, how we are going to integrate this?
Sir, from the 25 factors, we have found the 16 critical success factors, and from that we can give recommendations, the critical success factor recommendation for preparing a framework.
Okay, that framework, whatever you make, many of the cases, all the 16 factors may not arise. Am I correct?
Many, yes.
So, many of the times, some among will be missing, some among will be having influence factors to be very less. So how come you will incorporate that unless you make it as a single equation or something? Are you formulating an equation from this? Because we have shown
sorry.
You have done Cronbach analysis and all, right? You got a significance factor of 0.8 or something,
yes.
right?
0.846.
So, yeah, under that situation, why can't you come up with a single equation which could incorporate some among these factors which is very critical?
Okay.
So that part you have to ensure, because now all the 16 factors is standalone. You should try to integrate this. Otherwise, it's very difficult. No, in one sense it will be okay. In other 4 factors will be failing, and in other case, some 7 factors, other factors will be failing. So that you cannot say. It cannot be incorporated like that. So you just think about it. That's one of my suggestions from this side. And try to organize or limit your presentation to 10 minutes and plan accordingly. You have 41 slides, I understand, 49 slides, in fact, which is practically not possible in 10 minutes. Okay. So that is a information for all other participants also. Try to consolidate or speak whatever you have done in it. So that is very important. Okay. Thank you. Over to my co-chair, please.
Thank you, sir. You have started with mentioning the policies in Kerala, health and safety policies in Kerala, but nothing mentioned in your presentation about that health and available health and safety policies and its drawbacks.
That is the next part of the study. This is just the first part of the study. In the next part, there will be a comparative analysis and then interviewing with the success factor that I have achieved. And there will be another stage where we will develop a policy framework.
Okay. But you started with mentioning about the policies and health and safety policies. That's why I asked. And I also have the same concern as sir has pointed out. You have mentioned 16 are the critical factors and how you arrive at this 16 critical factors. And is the questionnaire you have you told that there are 6 questionnaire. Is the questions are the same for all the stakeholders?
No.
Then from this, how you arrive at the critical safety factors? Because one.
In each of them, I have given the number of. And in each parameter, I have given below the participant that have participated in that particular question. So in this question, there are about 88 of them participated out of 130.
Okay, so the different stakeholders responded to different questions and you arrived at the 16 critical factors from the response of different stakeholders and from different questions. Isn't it?
Not particularly different question, but out of 36 questions, some of the stakeholders.
How many are common to all?
Respond
Can you say how many questions are common to all the stakeholders?
About 5 or 6 or
A total number of questions to question in each questionnaire?
25 questions, total 25 questions. Out of them, many of them have, in some of them, insurance representative was a stakeholder. So they don't have to answer to all the questions that I have given.
Okay, okay, thank you.
Any questions from the audience? Sir, Vasudeva sir?
Yeah, you can move on to the next if there is no questions from the audience.
Okay, okay. Any questions? No. So thank you, Vishal. You can move to the seat. Next, we will have for 28.
Hello, please, I'm not listening to you. Is
Hello.
that any problem? Yeah, we are there. Please go ahead.
Sir, paper is ready. Can you see the screen now? Hello.
Not started. Please start the screen.
Share it.
Shared അല്ല presentation കാണുന്നുള്ളൂ.
Just a minute, sir. Hello.
വന്നില്ല.
ഇപ്പഴും വന്നില്ല?
ഇല്ല. ജോയൽ ജോർജ് പ്രസന്റിംഗ് എന്നൊക്കെ പറഞ്ഞു വന്നു, പക്ഷെ പിന്നെ വന്നിട്ടില്ല ഒന്നും.
നെറ്റ്വർക്ക് ആയിരിക്കട്ടെ. ജസ്റ്റ് മിനിറ്റ് കേട്ടോ സാർ, ഇവിടെ വിസിബിൾ ആയിട്ടാ കാണുന്നത്. ജസ്റ്റ് മിനിറ്റ്. ഹലോ, ഇപ്പോഴെത്തിയോ സാറേ?
ഇല്ല
ഹലോ,
സർ.
ഇപ്പൊ കാണും.
ഞാനൊന്ന് ഓഫ് ചെയ്തിട്ട് കയറട്ടെ എന്നാ.
ഒന്ന് ചെയ്യൂ സാർ, കാരണം ഇവിടെ ജിമീറ്റിൽ കാണുന്നുണ്ട്, പേപ്പർ ഐ ഡി കാണുന്നുണ്ട്. ഉണ്ടാവാം.
Yeah, please go ahead.
Okay, sir.
Yeah, please go ahead.
Okay. So good afternoon. So today I'm going to present on my paper on the topic performance analysis of cross-shaped composite columns with perforated steel plates, and my paper ID is 428. So these are the contents that I'm going to discuss today. So moving on to introduction. So concrete filled steel tubes, also known as CFST columns, are now widely used in large industrial buildings, bridges, docks, and piles. So compared to conventional columns, CFST columns have increased strength, ductility, and also energy absorption capacity. So CFST columns are known for its strong ability to bear compressive loads, and it has also been employed as a tensile component in real-world engineering projects. So the enhancement of CFST in structural property is due to the composite action between the constituent elements, which is steel and concrete, and the steel shell, which acts as a longitudinal and transverse reinforcement. So compared to ordinary square and circular CFST column, they protrude from the wall due to heavy load on the structure considered, and it reduces the usable indoor space. So to overcome this disadvantage, we can use special shaped CFST, which is done by which gives seamless connection between the special shaped columns and the surrounding infilled walls. So the figure shows the cross-shaped column. So next, in CFST tube, buckling near the mid-height of short columns frequently causes the column failure. So by optimizing the steel and concrete usage enhances axial strength, and multi-partition steel tubes provide improve concrete confinement and induce local buckling after steel leads. So the unique configuration of special-shaped CFST involves incorporating individual monocolumns at intersection of specific shapes such as cross shape, which is shown in the figure. So by providing plates compared to lacing bars, it increases the load-bearing capacity and structural integrity as connections between these monocolumns. One of the notable drawback of this CFST and monocolumn is that its susceptibility to corrosion, especially in harsh weather conditions, due to the exposed steel component. So moving on to abstract. This study focuses on enhancing the performance of CFST columns by replacing them with special shaped composite column. The special shapes such as cross shapes are created with the provision of individual steel monocolumns inside the concrete at the junction of walls. This ensures a seamless connection between the column and the wall, and it enhances the overall space utilization in efficiency of indoors. This steel is encased within the concrete to mitigate the risk of corrosion. The strength and cost-effective aspects of different models are investigated, and the optimum shape of the column is identified then. So moving on to proposed models. So in this 5 models are taken, and the first model is a cross-shaped PCC column because concrete excels in compression. Then the second model is CFST columns, which is taken to enhance the strength due to the presence of steel. The CFST is preferred over RCC for the lower steel percentage and higher load-bearing capacity. The CFST offers an economical alternative to numerous conventional columns for heavy loads. The third one is the monocolumn, which is based on journals with steel tubes linked by double plate filled with concrete, and it enhances the strength and stiffness. So by modifying this monocolumn, by embedding the monocolumn within the concrete and using a single plate connection, it is done to reduce the corrosion and increase the strength while maintaining the same steel volume but with increased thickness. The final model is a further modification of the fourth model, where the perforations were provided along the connection plates between these monocolumns, and the number of holes parameters were varied. So moving on to material properties and boundary conditions. So ANSYS software is used for column modeling in this study. So the material incorporated are steel and concrete. The material properties are shown below in this table, and it's adopted from a journal. And the boundary conditions taken are fixed end at the bottom and the top end is left free. In this, the single column model with a coefficient of friction 0.25 between the concrete and steel interface. So analysis of cross-shaped columns. So this table provides an overview of the analysis and the results, which will be discussed detailed in the coming slides. So as we can see, there's an increase in strength from compared to PCC for CFST and cross-shaped monocolumns. And again, moving on to the modified model, there is furthermore increase in strength. And in the final model where perforations are provided, the number of holes were provided like 5 numbers of holes per connection plate, 10 numbers of holes per connection plate, and 13, 19, and finally 24 holes per connection plate. So the first model was a cross-shaped PCC. So these models were analyzed through eigenvalue buckling, and the column length was 2 meters, which is maintained for all the models. The cross-sectional dimension of the PCC model was 500 in 500 into 95, and the FCK was 32.4 MPa. So the load bearing capacity obtained for this model was 12,072 kilonewton. Then moving on to the cross-shaped CFST column, here the same cross-sectional dimensions were maintained, and the thickness of steel tube used was 5.75 mm. So, and a quantity of 23,000 centimeter cube of steel was added in this with reduced concrete. So the load-bearing capacity obtained was 17,276, which showed increased strength. Then the third model, which is based on the journals, in this the dimensions were resized to approximately maintain same quantity of concrete and steel. So here the thickness of steel was 4.1, and the load bearing capacity obtained for this model was 28,104 kilonewton. The fourth model is cross-shaped modified column. As we can see, the monocolumn connected by single steel plate was embedded inside the concrete. Here the dimensions used are 500 in 500 to 106.4 mm, and the thickness of steel tube and plate is 12 mm, and the same quantity of steel was used. So here there was a load bearing capacity was increased to 35,654 kilonewton. Next, the perforations were added into the connection plates for the final model. So here same dimensions and same thickness of steel tube was taken, and the diameter of holes per provider was 50 mm. So the number of holes parameter is varied, and how the reduction in quantity of steel affects the model's strength was studied. So this table shows how the percentage reduction in strength compared to the model without holes. So for a total number of 20 holes with 5 holes per plate, there's a reduction in strength of 0.35. For a total of 40 holes, there's 0.52. For 52 holes, there's a reduction of 0.89. And for 76 holes, there's 1.04. And finally, for 96 holes, there's a reduction of strength by 1.33. So by introducing 96 holes in the connection plate, there's a notable savings in steel quantity by 8.84% with only 1.33% reduction in load-bearing capacity. So comparison of model with and without holes in the connection plate, the slope of the graph indicates that there's a reduction in strength with the reduction of steel. This also indicates that by providing more than 40 holes, the reduction in strength is more. So to provide an overall summary, the cross-shaped CFST calls an increase in load-bearing capacity of 35.46% compared to PCC column. The monocolumn, which is based on the journals, shows an increased load-bearing capacity of 47.72% compared to the CFST column. And then the modified column shows an increase of 69.44% compared to the conventional CFST column. Then the modified column shows an increase of 23.68% compared to the monocolumn, which is taken from the journals. So by introducing holes in the steel plate of the modified column, it ensures a better connection between the concrete and thereby resulting in less reduction in strength, along with the reduction in quantity of steel required. So by introducing 96 holes, there is only a 1.33 reduction in strength, but a steel quantity of 8.84% was saved. So it's the consolidated table showing the percentage increase in strength compared to the PCC, CFST, and mono for all the 5 models. So moving on to conclusion. So in this study, a special cross-section of cross-shape were modeled and analyzed for a composite column. The conventional CFST was modified based on the literature and by providing monocolumns at the junction and connecting them with double plates filled with concrete. The disadvantage of both models was the steel exposure, potentially leading to the corrosion in harsh climate, which was overcome in the modified monocolumn by featuring concrete applied exterior to the steel tube and plate connection similar to the monocolumn. To achieve cost effectiveness, the perforations were added to the connection plate, and the strength parameters analyzed are as shown below. So the CFST column showed an increase of 35.46% of PCC column. The conventional CFST column was modified to monocolumn and showed 47.72% compared to CFST. Then to overcome corrosion, the modified column was taken and it showed an increase of 23.68% over the monocolumn. And also perforations were added to achieve cost effectiveness. So 8.84% of steel was saved and only 1.3% of reduction in strength was obtained. So this work is at present limited to the analysis of column with this given dimensions and material properties. So further studies can be conducted to explore different dimensions and material properties. So the cross-shaped modified monocolumns with perforated steel plate reinforcement significantly improve the load-bearing capacity and addresses the corrosion concerns effectively. These are the references taken. Thank you.
The session is now open for interaction. Sir, I kindly request you to take over the session.
Yeah, thank you. And
Yes,
I
sir.
think the work has a sufficient quantum actually, it is there. But the thing is, what is the equivalency parameter is what actually? For example, you have taken 3 different types of sessions, right?
Yes.
So what matches here actually? There will be some parameters which is unique, and some parameters which is common to all. So
Yes.
what is unique and what is common to all? You have 3 different shapes, right? So each
Yes.
shape has its own well-being. and one
Yes.
thing you have given is on the either side you have given a plate. So
Yes.
that is as good as a stiffener, right?
Yes. Yes.
So that give a better strength and better parameters. But which you have kept as unique, and which part you have kept as common?
So for models from CFST, I have kept the quantity of steel as same. That is kept common. Then the parameter which was varied was the number of holes given in the connection plate. So also in the monocolumn, double plate was given. So in the final model only a single plate was given.
So in that case, do the weight of the steel that you are providing will remain the same, or will there be a additional weight over there?
The quantity of steel remains same because the thickness was varied in order to keep the quantity similar.
Okay, fine. Go ahead. Okay. My co-chair, please go ahead.
Yes, sir, thank you. How will you ensure the proper compaction of concrete in the case of double plate model?
Double plate model vibrate.
You are suggesting this for column.
Yes.
Is it possible to ensure the compaction of concrete?
For the monocolumn or the modified column?
Modified column.
Modified column using vibrator, then formworks should be provided. Proper formworks should be provided along with the vibrator. So
Is there any role for the you can use vibrator, but then what about the role of the formwork in the
in order to cast the external concrete, there should be a formwork, right? So
Sorry.
in this case, the steel is inside. For normal CFST, there's no need of formwork because the steel is exterior. So that's the difference one there.
for regular RCC column we are also providing the formwork.
Formwork, yes.
I am asking about the compaction of concrete inside this plate, all these things.
Plates.
Is it possible to ensure you think about that one? Okay.
Yes.
Then about the finite element modeling, which is the element that you have chosen for modeling the concrete as well as for the steel.
Concrete, it was modeled using space claim and the material properties was added.
No, element type.
Element type. I have to check now.
Okay, that you have to do. Okay. Thank you.
Thanks.
That I have just ignored asking because I think in his discussion, nowhere he has said about the elements or parameters that has been used for designing it. So that's why I just ignored asking that question. It's a very relevant question. Please go ahead, and it's very serious also. Okay. Please take care of it. Thank you.
Okay.
Any questions for the participants? So thank you, Akhil. Now we will move to next paper ID. Paper ID 434.
Please limit your presentation for 10 minutes. That is very important because time is already said. So please ensure that. Thank you.
Vasudev sir, can you see the screen now? The paper
Yes,
ID
yes, yes,
434. Okay. Then we start the presentation.
Good afternoon all. My paper ID is 434. So today I am going to discuss about the elements of durable self-compacting concrete incorporated with mineral admixtures and steel slag. So these are the content. Now move with introduction. So self-compacting concrete is a specialized type of concrete that is designed to flow without needs of mechanical consolidation, and that offers several advantages over traditional concrete, such as high workability, improved durability, homogeneous mixtures, and enhanced finish. So SEC production may achieve by employ the dosages of super plasticizers and using mineral admixtures such as silicon fume and fly ash, which produce highly deformable, workable, homogeneous mix without increases cost. Moreover, using silica fume in SEC enhance the durability at early age much more than other mineral admixtures. So, steel slag is another industrial byproduct is generated during the productions of steel. When used as a partial replacement for fine aggregate in SEC, steel slag not only concern the natural resources but also contribute for reduction in carbon footprint of concrete. So this research aimed to display how experimental study can lead to conclusion on issue of mechanical and durability integrity. So this is the figures of silica fume and steel slag. Now moving on object, to develop self-compacting concrete incorporated with steel slag and supplementary cementitious material, and to evaluate the shear strength property of different concrete mixes, and to compare the durability properties of normal SCC mix and SCC incorporated with steel slag and supplementary cementitious material, and to check the combined effect of supplementary cementitious materials and steel slag in SCC. Now moving on materials. So this is the material. 53 grade OPC cement is used, and fine aggregate. Then 12.5 mm downsize coarse aggregate is used, and potable water for concrete mixing, and Oramix 500 is used as super plasticizer, and steel slag. And steel slag is used as a replacement for aggregate, fine aggregate according to their specification, and fly ash and silica fume is used as a supplementary cementitious material. Now steel slag is a here steel slag is used as a replacement with a fine aggregate in concrete. So sieve analysis of steel slag is done, and steel slag is ensured to be in zone 2 and as same as that of M sand. So this is the figures of steel slag and steel slag used as a fine aggregate. Now sieve analysis of fine aggregate and steel slag. This is a comparative study of steel slag and M sand. So here we can see that it's belong to zone 2, both M sand and steel slag. This is the partial size distribution curve of M sand and steel slag. Here the blue line represents the particle size distribution curve of M sand, and the orange line represents the particle size distribution curve of steel slag. Now test results. Cement. So the specific gravity of cement 3.15, and fineness of cement 6%, and standard consistency 34%. Now fine aggregate. So the specific gravity 2.65, and it's belong to zone 2, and fineness more or less 3.88. Now coarse aggregate and specific gravity 2.82. Now super plasticizer. Here I used Oramix 500 as a super plasticizer, and it's light yellow colored liquid, and with the minimum pH, and the volumetric mass at 200 degrees Celsius is 1.10 plus or minus 0.02 kilogram per liter, and the alkaline content typically less than 1.5 gram sodium oxide. So this is the mix design for M30 SCC concrete mix. Here I have done 3 trials, and the final result trial is highlighted here. And this is the second control mix. Here silica fume is used as a supplementary cementitious material. This also I have done 3 trial, and the third result is highlighted here. Now the workability test of SCC. I have done 4 tests. First one is lump flow and V funnel test, then L box test and U box test. So the rheology properties of the mixes. From the table we can see that all mixes satisfy the range as given as per the code. For the mix with the additions of steel slag, we observe that it's satisfy the workability conditions. SCC mix without steel slag show good workability also. This is the slump flow of, then the V funnel test. Then L box, L box test and U box test. This is a mixed design for M30 grade of SEC concrete replacement study. Now here I use 25% of steel slag replaced with fine aggregate. And this is a second control mix here. Silica fume is used as a supplementary cementitious material, and 25% of steel slag is used as. Now compressive strength of comparative study of control mix and mix with CCM and steel slag. So this is the compressive strength result. Here I have used two SCCM supplementary cementitious material. First one is fly ash. In control mix of 7-day mean compressive strength is 19.54, and in 28 days 37.54, and also in M30 grade with SCC and steel slag. 25% of steel slag is used. So the 7-day of mean compressive strength is 24.17, and in 28 days 39.42, and then silica fume used as a supplementary cementitious material. So the in control mix 7-day mean compressive strength 22.48, and 28 days 38.90, and then M30 grade with SCC supplementary cementitious material and steel slag. 25% of steel slag is used. So the 7-day compressive strength is 24.19, and 28-day 40.27. So this is the graph. Here we can see that the compressive strength of the SCC is increases when steel slag is used as a replacer with fine aggregate. So this is the compressive strength of concrete cube after 7 days of curing, and this is 28 days of curing. This is 7 days of curing. Here silica fume used as a supplementary cementitious material, and this is 28-day curing. Now this is a replacement study. Silica fume with a steel slag, 7-day result, and this is 7 days of fly ash is used as a supplementary material. This is a 28-day of silica fume result. This is 28-day of fly ash with the steel slag result. Now durability test on concrete. Here I have done two tests. First one is water absorption test of self-compacting concrete. Then shear strength test on self-compacting concrete. Now water absorption. Determine the amount of water absorbed under the given condition. So this is the water absorption result. Control mix fly ash used as a supplementary cementitious material 3.95, and control mix silica fume 3.32, and steel slag replaced fine aggregate 5.3%, and steel slag replaced fine aggregate. Silica fume is as a supplementary cementitious material is 4.95. From the physical point of view, water absorption is defined as the amount of water.
Please conclude your presentation.
So in conclusion, materials were selected and tested, and the required values are tabulated. After the trial mixes were completed, the control mixes was chosen based on the result from the SCC workability test. By replacement of 25% of steel slag in concrete, reduce the workability of SCC and significantly affect the compressive strength. By replacing of 25% of steel slag to concrete, increases its toughness and fracture resistance and compressive strength. It is possible to increase the durability of concrete by varying the proportions of steel slag. So the value of water absorption is within 4 to 6%. When water absorption is below 5%, is considered to be a good quality of concrete. And also the by replacing on 25% of steel slag with fine aggregate, it was found that the shear strength characters has increased. Those are the reference. Thank you.
Moving on to interactive session. Sir, we kindly request you to take over the session.
Okay, the speaker actually has to understand there are many studies to be conducted on a durability study, because your title of your thesis itself is durability studies, right?
Yes.
So in the durability studies you have taken up only one single test, that is water absorption. Shear test is actually a parameter concerned to the physical properties, right? The strength parameters. It is not at all a durability study actually. So durability study pertains to water absorption, chloride penetration, like that. Many of the durability studies are there available, but we have just considered only one. So that is one among the query that I have put forward. And since it is an SCC, another one parameter to be discussed, SCC, you have many parameters to be discussed, because especially the flow parameters in that concern, you have only taken the flow diameter, right?
Yes.
So to confirm a concrete to be SCC, we have three important parameters to be discussed. First is flow ability, passing ability, segregation resistance. So what test you have conducted to ensure that, because it is an M30 grade concrete, to
Yes.
ensure the passing ability, as well as any figures pertaining to the avoidance of segregation is there. So that is one important parameter to be included in your paper. I have just seen your paper also, which has been forwarded to me yesterday. So these parameters need to be addressed very clearly.
Okay, sir.
Point clear?
Yes, sir.
Any of the answers is there for you in these two questions that I have put up?
No, sir.
Yeah. So please, and another one more thing, you have incorporated the cement, right? You have
Yes.
used IS 456 2000, this new code itself, or you have gone for FNAR?
What, sir?
Which code you have adopted?
I think IS for
IS 456. 456 is not for mixed design. SCC mixed design is available in 10262.
oh,
Because their powder content is very important. That powder content you have not mentioned anywhere in your thesis also, this your paper also. So please go through it. Okay.
okay, sir.
That's all from my side, and please pass it on to chair 2.
Yes, sir. I am also of the same opinion as Chair Vasudev sir told. Then many of the durability parameters to be considered is not included in the paper. And also, I wish to mention that after conducting the strength test, that is by showing the results of the compressive strength, just below the slide, there is no slide number. That is why I mentioned like this. Just before the figures 13 and 14, discussing about the strength parameters, your conclusion is about the durability. By performing the strength test, we couldn't mention about the strength, durability. Hope you got it. You have, can you take that slide? The slide just before figure 13 and 14.
Commercial strength.
Previous one. Okay, here you have shown the results of the compressive strength and your conclusion is it is possible to increase the durability of concrete by varying the proportion of steel slag. By conducting the strength test, we couldn't reach such a conclusion. For that, you should have conducted the durability test. Okay. Thank you.
Thank you, sir.
Any questions from the participants? Thank you, Mutasha. Now we will move to the next paper, paper ID 4430. Vasudev sir, can you see the paper 430?
Hello? Hello, Vasudev sir?
Yes, please go ahead. Please go ahead.
Okay, okay.
Good afternoon. My paper ID is 430 and today I'm here to present my journal on the topic Study on the Suitability of Powdered Solar Cell Waste as Sustainable Alternative to Cement and Fine Aggregate in Concrete. And these are the contents that we are going to discuss. And coming to the introduction, solar energy, which is a renewable source of energy, is particularly harnessed through photovoltaic cells. And these cells have experienced significant global growth with an annual increase of 40% since the year 2000. And the amount of globally installed PV panels is expected to grow rapidly. And the end life of the solar panel is considered as 25 years. And by the end of 2050, the total quality of the PV panels will become 9.57 million tons, and consequently there are limited research papers available on the proper disposal of these modules. And figure 1 illustrates the illustration, shows an illustration of the crystalline silicon solar panel. And a solar panel typically consists of aluminum alloy frame, tempered glass, a battery piece, EVA, and a blackboard. And from table 1 we could conclude that majority of the more than half weight of the solar panel is consist of glass. And this construction industry is increasingly prioritizing sustainable practices to reduce environmental impact. And there is a notable shift towards incorporating waste materials into concrete. That is because of the increase in the depletion of natural resources and also carbon emission that is associated with the cement production. So integrating waste materials into concrete production is seen as a crucial step towards promoting sustainable construction practices. Abstract. The study focused on the partial replacement of cement and fine aggregate with powdered PV cells. And the component of PV cells that can be incorporated into concrete is glass. And the PV cell modified concrete is tested for its workability, compressive strength, and water absorption. The material used are cement. The PPC grade of cement is used. Fine aggregate, which confines to zone 2, is used. Then coarse aggregate, 20 mm downsize coarse aggregate is used. Potable water is used. Admixture used is Oramix 500. And the PV cell powder is used as both fine aggregate replacement and cement replacement. Powdered PV cell. The powdered PV cell is obtained after removing the from the obsolete PV panels. The obsolete PV panels, the alloy frame, that is the aluminum frame, is removed, and the panel is crushed to use it as fine aggregate and cement replacement. For using PV cell as fine aggregate replacement in concrete, the sieve analysis of the PV cell powder is done and ensures that it is as in zone 2 as that of the M sand. And also for using it as cement replacement, again it is grinded into fine powder and made to pass through 90 micron sieve. The specific gravity of PV cell powder is 2.4. And the figure 4 shows the picture of an obsolete solar cell, and 5 shows the powdered PV cell which is used as fine aggregate, and 6 shows the powdered cell which is used as cement replacement. And the physical appearance of the PV cell powder resembles that of a glass powder, and its color is almost same as that of a powdered sugar. And X-ray diffractogram is done in PV cell powder, and it indicates that it is similar to it is having a graph that is similar to that of the amorphous material. Figure 7 shows the X-ray diffraction graph of an amorphous material, and 8 shows the X-ray diffraction graph of a crystalline material. And crystalline material have distinct peaks. And by comparing 7 and 9, we could conclude that the X-ray diffraction graph of PV cell is similar to that of amorphous material. And the X-ray diffraction pattern for a sample shows a major peak around 2 theta values between 20 and 40 degrees. And this is the characteristics of an amorphous glassy material. And the major peak observed suggests that the presence of amorphous silica component. Sieve analysis is done for both fine aggregate and PV cell powder. This table represents the sieve analysis result of M sand and PV cell powder, and according to IS 383/1976, we could conclude that both the M sand and the PV cell powder confines to zone 2. And this graph represents the particle size distribution curve. Then the brown color represents the upper limit and the green represents the lower limit, and we could conclude that both the M sand and the PV cell is within the limit. Then test and results. Cement used is of specific gravity 2.85, and the fineness of the cement is 6.33. Then standard consistency is 34%. Fine aggregate, the specific gravity of fine aggregate is 2.58, and sieve analysis zone 2 and fineness modulus is 3.88. And the coarse aggregate, the specific gravity is 2.7, and the superplasticizer used is Zoramix 500, and it is a light yellow colored liquid with a specific gravity of 1.1. And the replacement studies, according to the study conducted by Raju and Anand and Ragesh P, 5% replacement of cement by LCD glass powder is considered as optimum level with respect to strength studies. And according to the Safensi and Dhawan, 15% aggregate replacement with glass can be considered as optimum replacement, and the sustainability of concrete is increased significantly by replacing 15% sand without having any negative impact on the strength of concrete. And the workability test is conducted, and the workability refers to the ease with which the concrete can be mixed, transported, and placed, and the table represents the workability test results. And from here we can conclude that the mix replaced with 15% fine aggregate with powdered PV cell is having a higher slump value than the control mix, and the slump value increased with the replacement of powdered PV cell with fine aggregate. And in case of 5% replacement and 15% fine aggregate and 5% replaced cement combined, there is a decrease in slump value, and that can be due to the increased surface area and the water demand for finer particles. And this table shows the mixed design for M20 grade of concrete replacement studies. Compressive strength results. These are the compressive strength results. From here, we could conclude that the 15% fine aggregate replacement with powdered PV cell is having higher strength than the control mix and other replaced mixes. After a 28-day curing period, there is a notable increase in the compressive strength for 15% fine aggregate replacement, which is replaced with powdered PV cells, comparing to the conventional mix, and there is a 32.5% increase. And this observation indicated that when powdered PV cell, which is basically glass, when incorporated into concrete, enhances its overall compressive strength. The increase in strength is mainly due to the particle size distribution of finely grounded PV cell aggregates, that in turn improves the packing density of concrete and hence results in the reduced amount of void space. An increase of 17.51% strength can be seen in 5% cement replacement mix, and that can be because of the pozzolanic behavior or the filler effect of the 5% cement replacement. And upon replacing both the fine aggregate and the cement, the compressive strength is increased by 21.53%. And these are the figures. Durability test conducted on concrete. Durability test is done to determine the conducted to determine the resistance to physical or chemical deterioration of concrete. And the test conducted is water absorption according to ASTM C642, and 150 by 150 by 150 mm cubes are casted, and it is water cured for 28 days and then oven dried at a temperature of 100 to 110 degrees Celsius, and the dry weight is calculated, and then it is again immersed for 24 hours in water, and the wet weight is calculated. And the results suggest that the control mix is all the replaced mixes is having less water absorption than the control mixes. A reduction in water absorption can be observed in the concrete that is replaced with PV cell powder, and the reduction in the water absorption indicates that that it is more durable. When the water absorption is below 5%, it is considered to be of good quality, and also according to other data, water absorption of concrete below 10% is considered as lower water absorption. Hence, we can say that it is more durable. Sustainability aspect of PV cell modified concrete. The amount of globally installed PV panels is rising sharply and is expected to grow by next 25 is expected to grow by next years, and it can be seen that glass accounts for a large proportion of PV panels. End life of solar panel recycling can effectively save natural resources, and recycling extends the useful life of material. Instead of discarding materials at the end of the solar panel's life, they can be repurposed and reused to its maximum utility. It helps in the reduction of carbon footprint because 1 ton cement manufacturing results in the emission of 0.9 tons of carbon dioxide.
Please conclude your presentation.
Talking about the conclusion, there is a considerable increase in the strength properties when the fine aggregate and both the fine aggregate and cement is replaced with powdered PV cell. For 15% fine aggregate replacement, there is an increase of 32.5%, and 5% plus cement plus 15% fine aggregate replacement, there is an increase of 21.53, and for cement replacement alone, there is an increase of 17.51%. And the replacement of fine aggregate along with the powdered PV cell showed the maximum compressive strength. Both the fine aggregate, that is the M sand, and the powdered PV cell belongs to zone 2. Then the water absorption of the replaced concretes are lower than the conventional mix, and hence results in more durable concrete. Then inclusion of powdered PV cell as fine aggregate increases its workability. Then using powdered PV cell waste in concrete helps in reducing the impact of waste disposal on environment and helps in the production of sustainable concrete. Utilization of waste glass in concrete production not only provides significant environmental benefits but also enhances the performance of concrete when using it to optimum quantity. Thank you.
Moving on to the interactive session, I kindly request you, sir, to take over the session.
Actually, I have a question. Like now, present studies focus on something like removing that PV from the tube. It's in a tubular form that it is been coming, right? So unless you crush that glass, you will not get this glass powder away. PV cell, no, you will not get it.
Yes, yes, we
So-
have to remove.
Yeah, so that it will be removed and then you are crushing the glass to take the aggregates.
Yes, sir.
Okay. So what is the processing cost of this? That is very important, no?
Yes, I have done it manually, so I don't know about.
So in a small situation, it will be fine. But what
Huh.
about a large situation? Because you have to go in a massive stage, right? It's not that research should not end here.
Yeah.
So under such a situation, some plans has to be required to process this.
Okay.
So my question is, in a large scale, you said about sustainability. That's why my factor is, in a large scale, it is fine. But how much photovoltaic cells would be generated to create this much amount of fine aggregates to be utilized? That is very a question, right?
Okay.
എത്രത്തോളം വരുമെന്ന് നമുക്കറിയില്ലല്ലോ.
Ah.
Because once generated, it's over. Then we have to wait for another years together to get a lot of such photovoltaic cells, right?
Yes.
Which is to be discarded.
Huh.
So in a long run, probably this will not be that efficient because once a machinery is bought for a large scale processing and it is kept idle for a couple of years, it will be waste. Invested cost will not be received back. So that area you should be very clear, because now in your point of view it is fine because you have come across some enhancement in the compressive strength or so. It is good. But that too is very marginal. You should understand that it's only some percentage of increase is there, not much.
Okay.
So some sort of studies has to go into it. That's what my request is. It's just a suggestion. There is no queries in this side. Please go ahead.
Thank you, sir.
Hello, Gayatri.
Yes.
There is an increase in the strength for the 5% cement replacement
Yes.
as well as for 15% fine aggregate replacement. But why the strength get reduced when it is replaced together? that is together of 5 and 15%, the strength is less than that of the 15% fine aggregate replacement.
Yes, Miss.
What
5
may be the reason behind that?
for 5% cement replacement, conducting microstructural studies, I could see that there are voids. So when comparing when both these are combined, there can be the decrease because of the voids in the 5% cement replacement.
For
For
5%, can you
5%,
make it more clear?
yeah, Miss. 5% cement replacement when conducted the microstructural studies, I could see some voids are there, and that is the reason for lesser strength.
But for 5% replacement strength is more than that of your control mix.
Yes. Yes.
Even with the presence of the voids, the strength is more than that of the control mix.
But less than 15% glass. But when 15% fine aggregate and cement is combined, it is having more strength than 5% replacement.
I'm not fully satisfied with that. Oh, okay, then it's okay. Then I am also of the same opinion as was there told. From the research point of view, this is okay. But from the commercial or industrial point of view, you should think about or you should calculate how much amount we should spend for getting this as a replacement material. Okay, thank you.
Thank you.
Thank you, Gayatri, for your presentation. I request the chair of the session, Dr. Vasudev R., to share his general comments on the papers presented in this session.
Thank you very much. Actually, I'm very proud seeing that vividity is there, right? Two material science papers is one, that is your analysis paper is there, and another one was all related to construction management. So it is something like, people are thinking in a vivid manner. So for civil engineering, that is very important because vividity is very important. So first paper was all about ergonomics. Actually, it is something like, health and hazard and all factors, which the speaker has just said about the individual parameters, but the integration part need to be developed, which then will provide much clear idea about how we can go ahead with such factors also being incorporated directly into BIM or something like that. That is very important. And when you come to the second paper, actually his analysis is very robust. So much analysis has been done. Only thing is that the person should have a little bit more, speaker should have a little bit more clarity on the specific elements that he has used and what all parameters he is keeping common and what else he is going to get it varied. So that pattern, many of the times it is a very generic that if you have a stiffener, probably it will add on to the strength. So that is a very generic parameter. So that he has already proven. Non-thing he is getting proving again. So it's an attempt. Actually, it is very good. Actually, it is to be done because one's learning should be emphasized. So that part is clear on that. Coming to two other papers, it is all about the materials. Specifically, the title and the work should match. The first one, the title was all about the sustainability factors, durability factors, not sustainability factors, durability factors, but the durability study bit more had to be improved. But his attempt on M30 grade concrete and its SCC part, it's very nice, but my request is it's a marginal flow factor. It should be more than 700 or something like 740, 730 you will get because you are using more of that is your mineral admixtures and also chemical admixtures you are using. But since that material used is of silica fume, probably it is sticky in nature, that reduction in the flowability has been occurred. And in the last paper, it has a wide scope, but periodic. That is very important. Sustainability factors, it's a big question mark, like over a period, what is to be done with all these photovoltaic cells that is going to be established here and there. But you should always understand commercialization is very, very important because civil engineering, the major drawback is everything restricts towards the research. And it will not go out as a patent or it will not go out as a product or something. So the last speaker should always think about how that commercialization part has to be taken care of. So I wish a SECON a grand success because this type of vivid papers, now I've just seen only 4, and I am a reviewer also. I have reviewed around five or six papers. So all the papers was it gave me many insight, and it's very nice that it has been get organized very nice way and in a very meticulous way. And hats off to the entire team of SECON and to all my young budding engineers. Unless you express yourself, unless you get a criticism, you will not develop. So this, whatever we said, it is myself as well as co-chair or chair 2, whatever is said is for your development. So take this or think in this angle also. Maybe we will be wrong. So you should think in this angle so that you will have an answer for it. So that's all from my side. Thank you very much for giving me the opportunity. Thank you.
Thank you, sir, for your feedback. With this, we have come to the end of the session. Thank you, Dr. Vasudev R. and Asha Joseph, for joining us today. And thank you, others, for your kind participation. The session is over.
Hello, Vasudev.